Welcome to our NANOG tutorial for this NANOG. My name is Barry Green, and up here with me is Brian and Chris from UNet.
I'm Brian.
This afternoon is more of a session that we've been trying to work on for a while for ISP security. There's been several people who talking to me over the last couple of NANOGs trying to get me out to do a tutorial on ISP security. I do that, but I do that under the hat of Cisco, which isn't really what we're looking for here in this forum. What we're looking for here more in this forum is more of an operator's viewpoint versus a vendor's viewpoint of ISP security. So in me bumping into Brian and Chris this summer, we talked about this issue of getting more of a operations perspective of ISP security. And so this is our attempt at it with this tutorial to talk through it. This is more of an interactive afternoon, so as we are trying to explain some of the techniques that we see people should be using out there to counter security threats, please feel free to raise your hand any time and ask questions at any time. We are ready and willing to make all sorts of digressions so we can get everybody here understanding what's going on with these different techniques that people are using to counter security threats. So our primary focus here is not so much vendor talks, it's more of the techniques. The techniques that we have here are primarily vendor independent. In other words, it doesn't matter what sort of router you have in your network. You can have, free routing code, gate these sort of thing, and these techniques would work out there. So we're trying to keep those techniques out there are vendor independent techniques. Any sort of vendor specific feature functionality questions, we're going to try to push towards the end when we get to the wide open Q&A towards the end of the day, and so we can do digressions towards vendor specific things towards the very end of the day. To start out, I'm going to do a quick on the introduction part of it, and then we'll get into some of the techniques, and then as we get into techniques, we'll take a pause, and Chris and Brian will jump in and talk about their experience of using these sort of techniques in the unit operations, how they use these techniques. First thing to kind of keep note is there's no magic knobs out there of ISP security. I know wearing my Cisco hat, I've been talking to you as customers and operators, and people will be in meetings or in conference calls and say, hey, we need a feature from Cisco that will solve this problem. And I try to tell them, well, there's no such thing as a feature that's going to solve the problem when it comes to security. Security in today's world is very much of a arms race scenario. You'll come up with some sort of counter, and the attackers will figure out another way around it. You come up with a new counter and come up with another way around it. So there's no final solution where it comes to ISP security. You're going to be constantly in there coming up with new counters, new techniques, new attack profiles are out there. It's constantly an evolving area. So you can't just say, boom, I've configured my network and my network's secure. It's never going to be that way, unfortunately. Likewise, there's no rocket science in a lot of the fundamentals. I think key theme of this talk is to hammer through that the techniques we're talking about are not super complex sort of techniques. They're very fundamental techniques that you can try over and over again and use variations of them over and over again to cope with the different sort of attacks out there. So it's not rocket science. It's some key, very fundamental basic themes. And also to keep in mind is there's no blanket solution. Every network is slightly different from every other network in the way you as engineers put together and operate your networks. So a feature combination or technique may work well on one network scenario and may not work well on another scenario. So what you're looking for is somebody who does ISP security, counterattacks, helping your customers counter attacks, is you got your bag of tricks. And you're knowing your bag of tricks and know how those bag of tricks are going to work and how to apply it with different attack profiles or how your particular network's put together. That's what you're looking for. Don't think that, oh, here's a magic feature and if I turn it on everywhere, then it fixes the problem. You can't. It doesn't work that way. We get that with, for instance, ingress filtering. route filtering. People say, oh, if everybody just turned this feature on everywhere, if everybody does ingress route filtering or ingress packet filtering to make sure there's no spoof packets coming in, then the problem will go away. Not really. Not really. I mean, and some networks are set up in such a way where it's very difficult for them to do that sort of ingress packet filtering to prevent spoof packets. So we've kind of broken this down into four different or three major sections where we'll talk about briefly what I've seen working with different internet service provider security operations teams, how ISPs are breaking down the phases of how they're countering attacks nowadays. And then we're going to spend a lot of time on some of the key foundation techniques. These are techniques that you should all know very well and be able to use. So we're going to be spending a lot of time on those. And then we'll do some digression towards the end where we'll go through more detail of the 6 phases. And again, remember, through this all, just raise your hand, interrupt us to ask questions, clarifications of how some of these things work. And as you see down here, we've Chris and Brian put together a demo, so we can actually demonstrate a couple of the techniques, so you can see it live, right, on the network. So 6 phases. My role in Cisco over the past year has been working with different ISP security teams in coming up with techniques, coming up with feature combinations, coming up with new code, and wearing the Cisco hat to counter ISP security threats. One of the key things I need to do when I talk with you as a operator is to try to understand how the processes you go through to work those attacks, to counter those attacks. When the phone rings and one of your customers are attacked, what do you do? My observation has been that we can break this down into 6 different phases. Preparation, which is probably the one that takes the longest, and actually shows which ISPs have their act together and which ISPs don't have their act together. It's how much time they spend in the preparation phase. The identification, where you find out, okay, there's an attack in progress. How do you know the difference between an attack and a network outage? There's an identification stage you go through. Classification stage, so you understand what sort of attack is going on. And that's kind of really important because certain sort of attacks require certain reactions, and how you're going to counter those attacks. So there's a classification stage. Trace back, finding out where that attack's coming from. Reaction, where you're going to do something, whether you're going to do something about it in the post-mortem stage. So preparation, which we'll talk a lot about towards the end about it, is the key thing that I've noticed that, and actually some of your customers, those of you who are internet service providers, your customers, me talking to some of the big co-location providers, what they've noticed is that the ISPs who can react quickest to the attacks, when you look into it, you find that they have spent the most time in the preparation stage. They spent the most time in working on techniques, tools, scripts, procedures to be able to handle and work the attack incidences as they're reported in. So this is preparation is key. Identification, this is something you get a lot of, we've had a lot of talks on this in past NANOGs with intrusion detection systems. It's an important stage, but the fact of the matter is, today, the state-of-the-art of identifying an attack is basically your customer calls you up and say, help, I'm under attack. And then you say, okay, there's an attack scenario in progress, and you start working it. Classification, understanding what type of attack is going on. That's important because it's going to depend on, whether it's a Smurf attack or some sort of flood attack. If it's a flood attack, what sort of source addresses are being used? Are there valid source addresses? Are there spoofed source addresses? Are there spoofed source addresses out of the entire internet address range or a specific range? These are sort of things you got to figure out in the classification stage, because it's going to depend on how, one, you trace back on the traceback, what sort of traceback technique you use, and two, on the reaction stage, what sort of reaction you're going to do. Give an example. If you classify an attack and you see an attack where you got a customer who's a T1 and you got 6, 7, 8 megabits of traffic flooding into that T1, you're seeing packet loss on your aggregation route. You're seeing packet loss somewhere in your network. You got to think about, okay, where do I put an access list? If I want to jump in there and put an access list and drop the packets on behalf of my customer, where am I going to put it? Well, if the flood is at a 6-to-1 ratio, that's something you got to know before you put a reaction stage in there. So that's why the classification stage is important. And then follow on from the reaction to post-mortem. I see many providers, just the nature of our business, because we live in such a hectic business and time is a scarce resource out there, that there's not enough time spent in the post-mortem, where people say, okay, I've been attacked, or my customer's been attacked, and this is what we did, and attack's gone away. What else could we do? Could I have done something better? Can I improve my scripts? Or I just created this script to look at this. Can I improve that script and save the script? You know, don't wait for the next attack to happen and say, oh, what was that script I used last month? You know, that's where the post-mortem comes in. So, so those are the 6 phases that I've personally noticed in helping working with different ISP operations teams and seeing what they go through in their operations. Now, on the foundation techniques, in talking over Chris and Brian, we kind of got 4 basic foundation techniques that we see ISPs should know really, really well. These are all vendor-independent techniques that if you're not using them, then you should be set up to use them. Okay, and so we set up with the demo so you can see that these things sort of work, because we get some questions in there. And please, if you see one of these techniques and you say, well, wait a minute, but that's where this is the opportunity to raise your hand so we can talk about it here, about the different limitations you may see to say, well, wait a minute, that technique may not, work in all scenarios. And now we're not saying that all these techniques are going to work in all scenarios, but we want to hear that sort of feedback, that interaction. So, first one, classification traceback. This is kind of like probably the fundamental technique out there that we see people use. This is where essentially you're using an access list and you're turning your router into a pseudo sniffer. Given a scenario where your customer is calling you up and say, I'm under attack, help, what should I do? You can take a classification ACL where you take all your ACE entries, your access list entries, and you put a series of permit statements in there. And then with these permit statements, you'll be able to see either through counters or using log inputs, log statements to see some of the packets that are flowing in there, and you can get information out of it. So I'll give an example with, let's go back. With the Cisco one, here's a classic example you see in the Cisco classification ACL, where you have a bunch of permits, and I go through the different protocol types. So I have ICMP, a few ICMP in there, a few UDP in there, a few TCP in there, and IP any. And what you're doing with this is you apply this access list in on, say, like outbound access list on the T1 going out to your customer. And then you'll use a show and look for the counters, look for the matches. And this is kind of like a first stage of looking at what is going on. If all of a sudden, like in this scenario, you got a customer who is getting smurfed, so you see lots of ICMP. Say, okay, this gives me a clue. I see lots of ICMP, this is abnormal. Then the next stage, what you would do on classification is go through and do the log statements. All right, so you do the log statements. Now, classification traceback, the differences between classification and traceback. Classification, you'd put it just on one router, most likely going out to your customer, all right, on the aggregation router. Traceback is when you're going to use the same access list and you're going to go capture a spoof address, and then the traditional technique is you go hop by hop. You do a classification ACL, you see what interface the packet came in from, because usually like a Smurf attack or some of the SYN floods out there, the source addresses are spoofed, so you can't do a trace route on a spoofed address. So you got to find out what interface it came in on. So it's going out serial 01, you got to say, okay, it's coming in Ethernet. And then you go to the router that Ethernet's connected to. And on that one, you do the same thing. And you go to that router, next one, same thing. So this is what we call a traceback technique. So when you do this traceback technique, some of the things that we've learned over the years is preparation is key. I've worked with ISPs who go in there and start doing the classification ACL, and they didn't do things like make sure they had the login large enough. So make sure the login buffer you have in your routing device is large enough. pre-create the ACL before you don't log in the router and just start typing the ACL. It's a good idea to create the ACL offline and then log it in, cut and paste, or write it into your operational config. Watch out for things like login messages to console V2Y. Okay, seeing guys where they put on a classification ACL and they do a log, and they have login going out to console, and the attack is so much that you'll have your log statements start overwhelming the console, and the console is interrupting the router, and then the router starts getting into this where you can't log into it anymore because you just locked up your router. You just DDoSed yourself by putting on a classification ACL with the login all going out the console port. So these are kind of like little hints when you do the classification ACL. So here's another classification ACL where I'm going through and doing a log input on echo reply, looking at a Smurf attack. I set it up where I put this in and I take it out, because when you do a log input, you don't need to put it on there and keep it on. You just need to put it in. Once you put it in, you're going to capture some log message and you take it out. Then at that point, you go and you look in your log. Then at that point with your log, you're going to see information in here. Like in this case, I'm seeing spoofed addresses where the guy is using RFC 1918 addresses, and they're spoofing with those addresses. But I'm also seeing which interface they came in from. So I'm tracing it back. I now know, okay, I got to go to serial 1. What router is serial 1 connected to? Now I go to the next router. And I start working this back. Now this is the limitation of this technique, because the limitation of this technique is you got to go hop by hop by hop by hop by hop. Okay? So this is an important technique. Everybody here should know how to use this technique. Everybody here should be prepared to use this technique. But the key limitation of this technique is it takes a long time to go hop by hop by hop by hop. So a customer calls up and says, help me, I need to trace this attack back. If you start using this technique, you'll be on there for, I don't know,
8 hours.
8 hours. a long time there. So it's this sort of scenario where you're going from router to router to router by hop technique. And that was kind of like when the February 2000 attacks hit, a few nanogs ago, because it was at a nanog that those attacks hit. This technique was kind of like the state of the art. All the ISPs who worked this attack kind of use this technique, except for one that I know of that use a variation of a net flow technique to do the traceback. Everybody else uses technique. Now since then, as we go to these other techniques we'll talk about now, we've got some other tools and other techniques that we're going to start talking about of how we've come since February 2000 with these different techniques. So let's see, Brian, Chris, your operational experience. I mean, what do you see UUNet and using this technique? And also questions, if you got questions on this.
Okay. So, like Barry said, as of a year and a half ago or so, the hop-by-hop tracing was kind of the only thing that really any of us could do without, if you have a large network, you can't SNMP poll every device every minute to find out what's going on. And you really can't get the data that you need from SNMP easily. So the problem is that, like I said, I've spent 8 hours on the phone with a customer, pretty much getting every router on the West Coast and Dallas-Fort Worth area, every single device, trying to find the traffic. And the problem with the hop-by-hop tracing is, if they don't use spoofed addresses, you can get to the point where you're tracing legitimate traffic, and all of a sudden you're tracing legitimate cable modem traffic to CNN.com, not the actual attack traffic. And it's not only can it be confusing and difficult to trace hop-by-hop that way, it can be very destructive. For a long while, in our core at least, for a long while, GSRs wouldn't log traffic properly. So we had to hunt the traffic off with Ethernet on the GRP to get it to work. It's just horrible. And a quick way to crash the router, unfortunately. So you have to know your equipment and your network, and you have to know what capabilities you can and cannot get out of that, which is part of the early foundation stuff that you need to figure out. So, and instead of the traceback, we have
go backwards.
You going backwards or forwards?
Forwards.
Forwards. Okay. going to do black hole filter next.
Okay, yeah.
All right.
So when we initially, when I first started in the beginning of 2099 with UNet, the only way we could really deal with any customer problem was to access list it or just null route their traffic on our device the customer connected to. And kind of, I'm pretty sure that pretty much everybody did the same thing because it's really just one solution for the problem. Drop the traffic from an access list for a route. And what we started to notice is the floods started getting bigger and bigger, and they were starting to really, our equipment was actually taking some hit in that. And you know, if you get a 300 meg flood, you know, some of your customer traffic is going to be affected by that flood. So Brian and this other guy, Robert Stone, Robert might actually be here in the room today, but anyway, Robert used to work at GNet, and he kind of said, why don't we do this thing called a black hole route server? We all kind of looked at him like, what are you talking about? And after looking at it, it really, really helps us in our scenario. We can drop, and it actually help anybody. You can drop traffic as it comes into your network. So the idea with a black hole route server is to set a single static route on all of your boxes to null zero, and then set a special next hop on certain static routes off of the special box of the black hole route server to go to that next hop. Does anybody not understand that?
Just build up to that.
Yeah.
We got some slides to build up.
Plus, you can also use, there's more to, you get an added benefit out of having a black hole route server than just stopping attacks. If you have somebody attacking your infrastructure or port scanning your corporate network and you don't want to see their traffic anymore, or you just want them to go away, you don't want to put filters on every one of your corporate network points. You just black hole their traffic. The SIM packets come in, they never go back. They don't get any data back. It's an easy way to do some kind of intrusion prevention in 5 seconds. You just make that person go away. They no longer exist on your network. Sometimes it gets to the point where you have people going after your infrastructure and your corporate network where you have no other alternative but to make them stop, at least initially, and then try to figure out what they're doing and why they're doing it. And if you black hole the traffic, you can actually see the inbound packets and see what they're trying to do. They just never get a reply of what they want. They never get a synapse back for their port scan or their reset packets or whatever they're looking for to get out of their port scans or their SNMP runs. They're never going to see that traffic back, but you still can see the traffic initially being sent in and try to figure out what they're doing while they get effectively nothing back. It's very effective for stopping intruders quickly on your corporate network or your backbone.
So,
very helpful.
So the foundation of the black hole, because we had some confusion, and actually it was expressed a few nanogs ago when people started talking about unicast RPF and getting all confused between ribs and fibs and what's going on. But black hole, traditional black hole, what you're doing is you're forwarding to the bit bucket, right? It's not an ACL process. Black hole filtering is filtering where basically you're setting an entry in your fib, forwarded information base, where you're forwarding traffic to the bit bucket, okay? And you can do that with a static route to null zero. The benefit that we got with today's equipment is with ASIC-based forwarding, because the trend with the industry to get the speeds and packets per second is we're using mission-specific ASICs. Is mission-specific ASICs, it's just a cloggable of a talk and you drop the packet. So you can drop forward to the bit bucket at line rate on any of the ASIC-based forwarding devices out there in the industry. So it's a very efficient way that you can drop a lot of packets that you don't want. And this is a traditional black hole filtering is destination-based. Because it's forwarding, all you're looking at is the destination field. All right, so you're destination-based dropping it off. Yeah.
So I think the really nice thing with routing to null zero, the reason why a lot of people will use it is it doesn't take no processor impact on the router, right? I don't have to access list the traffic. I don't have to send all that traffic up to the GRP or up to the route engine, the route processor, what have you, and figure out what to do with it. It just says, this stuff is going to null zero, just drop it, and it gets rid of the traffic. So if you have a really large flood that you can't access list because your line card on your 12,000 is going to go to 100% and you'll start dropping packets or what have you, if you route it to null zero, the traffic come into the router and just never go out. So it'll die with no processor hit at all. Well, pretty much no processor. I haven't tried pushing yours through 48 to null zero, but it's pretty effective.
Right. So the simple what we're alluding to with the remotely triggered black hole filtering is that kind of like the next step. This is where Chris was mentioning, where you can put a preset preparation. This is the preparation stage where you're presetting static routes out on the network. And this is kind of like an example of it, where my favorite is to use the testnet. Testnet was one of those blocks of addresses out there that was originally reserved and not supposed to be advertised on the internet to do technical documentation. And I'm pretty sure you've seen it, and I've seen it, where you had customers and they open up their manual for whatever TCP/IP application they have, and they open up the manual and they copy the addressing plan from the manual. I used to have one particular LAN vendor years ago. I ran into one company and they copied it exactly. Now all those addresses they put in documentation was somebody else's addresses. So testnet was allocated for people who did technical documentation to use a address space that was never supposed to be advertised on the internet. The problem is it's only a /24, and technical writers usually don't know how to subnet properly, so nobody ever used it. So here's a /24 that's never supposed to be out there on the internet that's reserved. It's a good address to put as a static to null zero. It's not going to hurt anything, because the address block shouldn't be out there. So you put a static to null zero out there. So what you can then do with BGP is you can then export whatever you need to export with a static route and set the next hop. Reset the next hop. So you take a particular flood you want to drop. You take that particular address, say like a customer. Well, you take a scenario.
Yeah. So if we have a customer that's under attack and it's a large flood that we don't, for one reason or another, we don't want to access the traffic. There's a number of different reasons, but let's just say we pick, don't want to hurt my routing equipment. Log into our box, which is our black hole route server, and you'll have the same thing in your network if you do it, and basically say route the destination address, the guy's shell server that's getting smurfed, to route it to, in our case, we route it to null zero and then set a tag on it. And then in our route map, we use a Juniper, not a Cisco, but it doesn't matter. It's a route map and a tag. We take any tagged routes in static table and just set the next hop to be the black hole IP address. So as the route goes out across our backbone, it says, shell server is now accessible through this special IP, which every box has a locally connected route to null zero. So every box, as the traffic comes into the router, it just dumps it immediately.
So when you get this and this advertisement goes out, understanding the ribs and the fibs and stuff, here you have going into your BGP process off to the right, you get this advertisement coming with the address. In this case, 171.168.1.1, and this guy's getting attacked. And you've reset his next hop where it equals that one of the addresses in the testnet. And you also got it set up with keep it safe, you do no export. BGP will then take it and say, okay, I'm going to send it down to the fib, 171.168.1.1 equals 192.0.2.1. But down at the bottom there's a static route. The static route is that 192 address equals null zero. And the way your rib and fib logic works is BGP sent the next hop, your static route equals null zero. You glue those together, and then what happens in your fib is you have adjacency markers where now you have the 171.168.1.1 is now equal to null zero. And that gets triggered on all the routers that you've set this static route out to that receive BGP. So instead of having one aggregation router that's receiving, megabytes of traffic, you now have all your edge routers dropping the attack maybe at kilobyte speeds because it's a distributed denial of service attack.
Plus you're not paying the transit attack traffic because you don't want to transit anyway.
Right. There's no sense in transiting 300 mega traffic just across on one router.
Across the Atlantic Ocean from there.
Or across the
costs money.
It costs a lot of money. In some way it will end up costing you money. More links you have to buy or what have you, more capacity. So it saves you something there.
Chris.
Sure.
Okay.
One more back?
The config bits?
Yeah.
Oh, so how you do the config? There's several ways of doing it. This is just kind of like one way that I just wrote up, where This gave an option where you match the tag, the static route. If you put so all I need to do here is all I need to do is go on to this particular router that's set up to do this and put a static route with the tag attribute on the static route, and then that will come in. I'd set the next hop, and I put a local preference on it and set the no export community, so I don't have this. Say if this was a /32 advertisement, it wouldn't go out that way.
Hopefully,
no origin.
Yeah, hopefully at your peer connections or customer connections, you're not flooding down 30s and 32s to the customer. Hopefully you're sending 24s or whatever it is that Aaron says you should be sending today. Right. So hopefully that route wouldn't get past that filter anyway, but adding the no export is a good extra touch just in case.
Right.
We should probably do that on. The local prep is nice though. The reason that we set the local prep low to 50 or whatever you want to set it below, like your default 80, is in case, it'll bite you too, but in case you need to reroute this traffic someplace else. I can black hole the traffic now and then just put in a competing route someplace else and suck the traffic off. So there are times when customers said, I want to know exactly what that attack is. And I've already filled the traffic off in my black hole route server, and if I pull that route out, the customer will get flooded again and they'll call me back. So what I can do is jump on to a router that connects up to some network, which we go later on into the sinkhole network, right? So I have a OC12 connected lab, so I just dump the traffic off to my lab and TCP dump it inside my lab, right? So I can take the customer's traffic, the /32 that's null routed or black hole, I can route it down to my lab without having to mess with any special stuff on my other backbone route. It connects my lab up. And then look at the traffic in TCP dump or Etherreal or whatever it is that you fancy is a good package.
You save your customer from getting this bad stuff, but now your customer's getting nothing at all.
Nothing for that one IP. Right.
In source extraction as well?
No. Okay.
One of your customers.
Yes. So the customer. Okay. I run a shell server at home. It's called chrisshellserver.com. Right. I have some guy who just angers everybody on the internet. And so every 3 days, he pisses off somebody, and I get flooded. And I get like a 500 meg flood. And I call up my ISP, which is me, and I say, hey, I'm getting attacked again. And Brian answers the phone. He says, is it your shell server again, Chris? And I say, indeed it is. And he black holes it out for me. So until the black hole is removed, that shell server box won't get any traffic, at least on its main IP. Shell server, a bunch of Vivos. You know, I love Cisco.com, you know, my other one or whatever. Not that I love Cisco, but the point of the matter is, you know.
I mean, this technique has a place for everything. It's not a be-all and end-all.
But it's a useful tool. The key thing why this tool is extremely useful is, number one, you can update your entire network and drop at the edge of your network at routing protocol speeds. So here's where preparation is key. You set up a router with a script like this that you can just log into and add a static route. Once you add that static route, a BGP advertisement goes out across your network. Once that BGP advertisement goes out across your network and your RIBs are updated and your FIDs are updated, you start forwarding traffic to black hole all over your network. Right? Now, this is also where classification is important, because say if it's a T1 customer and it's just a flood that still fills up the T1, that's okay. But if you've got distributed denial of service attack pounding that T1 on the aggregation route, you're getting 100 megs of traffic hitting that little T1, well, your packets are going to be dropping somewhere, and they're probably going to be dropping in place in your network that you won't want them to drop. So you may want to say, I want to push that packet loss out. Let me push it somewhere else. Let me push it out to the edge of my network instead of having all pound my aggregation server that has 1,000 customers on it. You know, say, wait a minute, I don't want to have packet loss there where I have 1,000 other customers on it just with that one customer getting pounded. Yes?
Could you ever find it useful to, especially for distributed packets, sometimes try to block 99% and somehow squeeze it and let a few of the packets come in all the way down to the shell server so that the attacker thinks that it's still working.
Right.
So I'm going to log it, and even let the customer try to do some of the analysis rather than having to log into your edge router and look at the traffic all the way back to the block and do just one little round around for some of the traffic.
So his question basically is, can we rate limit the traffic down to, like, you know, let 1% through or 1/10 of 1% through, right? That basically.
Yeah, exactly.
Okay. This is the problem with rate limiting. Okay. Rate limiting traffic works very well for well-behaved flows. Okay. So TCP traffic, for instance, if I want to rate limit all web traffic to my web server down to the smallest I can do is 8K. I can rate limit it down to 8K, and only 8K will get through, right? As soon as I start flooding, okay, the reason only 8K is through is TCP will open or shorten the window size to adjust. Everybody who's trying to connect will adjust their window size so that they just get 8K because they'll get packets that are dropped. So that's well-behaved flow. Right? It's supposed to do that. It works properly. Everybody likes that. If you have an attack, if I'm just using sig4.c to attack the web server, my web server will get 1 meg worth of traffic, and it'll get rate limited to 8K. So everybody who's well-behaved will say, well, I'm dropping packets like crazy, I better slow down. So they slow down to nothing, and there's still 1 meg of flood coming through. So you'll see all flood traffic. It doesn't necessarily benefit you to rate limit that traffic, because you're not saving the customer.
Yeah, you're actually making the attacker's job easier.
Right. You're making the attacker's job easier, because they only have to flood with a smaller flood. Right. So in some instances, it's not really beneficial in most instances, it's not beneficial to rate limit traffic like that. We use rate limiting as a side effect because we have to in order to get certain other things to work. Which we'll explain a little bit later. And if I forget it, just ask and I'll explain. Okay. So the deal you're asking is, what if you just want to drop some part of the traffic, but you still want to figure out what's going on?
That's
right?
kind of the point. It wasn't a rate limit solution. The rate limit as a technique to further analyze.
Okay.
Rather than block out the attacker, he has a way. Maybe the typical attacker doesn't care if he's flat and the packet gets dropped. Well, somewhere else is flat, somewhere else doesn't.
He doesn't care.
Yeah. Most don't care.
They don't care.
Most don't
They're 14-year-old kids.
And they don't necessarily understand the structure of the network either, and what it turns out a lot of them don't really understand BGP or ISIS or routing in general. They understand the box is over there, and the box and the packet's there, right? So that's certainly the case. But if you want to analyze it, that's where having a lab network that's decently connected comes to your benefit, or a network that you can blow up, because frankly, you're going to blow it up, right? You push 500 meg down to OC12, it's going to explode, right? So something down there is going to have problems. So you need a network that you have control over, that you can blow up, hopefully not connected to the same router as your corporate network, so in case you blow that router up too, you don't disconnect yourself at that time. But definitely you want a little lab network that you can push the traffic down, and you can put it to a Linux box or Sun box, whatever, so you can look at it, right? Or just a dead Ethernet with a sniffer on it. I really don't care. Push it down somewhere that you can look at it, and that's really what you want to do. Sending it down to the customer, I don't think we've had a single customer that really even cared
They
to
just
look
want
at
to
it.
stop.
Even really large customers, they just want it to stop. Make it stop, right? Even really big, especially the really big customers, they want to stop, and they want you to then let their site go back to normal. So use the Blackwell route server to drop the traffic, find out where it's coming in, and then block it at our ingress with an access list. And that's kind of the standard way that we do things. If we care a lot about the customer, not that we don't care about customers per se, but if it's a big customer, anyway, you get the point. If it's somebody that you feel some kinship with or whatever, you'll go to the nth degree, you'll track the traffic back to them, you'll stop it at your edge, and you'll say, found it, stopped it, everything's back up and normal for you, except for this one little section of the network won't be able to see, right? If you don't care so much if it's a shell server and it's 5 in the morning and the guy just got attacked 2 hours ago, kill the shell machine off and just call it a day.
The customers I've been working for about a year ago, when I was making the rounds and trying to figure out what Cisco should be coding and working on, I broke them down to two parts, and it was ISPs. It wasn't really the customers wanted to see the leak when you drop in the attack. There was a class of customers who just wanted to drop it, put an ACL, a black hole filter, and push the packet loss out to the edge, until the problem went away. And there was another group, and they didn't care about going and capturing a guy and locking him up and lynching him. And then there was another class of ISPs who wanted to watch the attack, keep on working the attack, keep on working it back all the way to the source, and they wanted to grab the kid and lock him up. So it was more of a mentality of what it wanted to do. But in working through what you see, the next techniques we'll talk about, there are ways you can still do that as an ISP. It was only ISPs asking for this. The customers weren't asking for it. Because ISPs are all asking for a rate limit kind of leak, sort of, so they can keep on tracking the attack back. But these next couple of techniques, you'll see that you can do that without having to do the rate limit. Because to do the rate limit, you have to have a remotely triggered rate limit on the entire edge of your network. It's not just one place. You got to do it all at the ingress on the entire backbone and be able to remotely trigger it. You can't go in and with rate limits the way they're set up today on Cisco Juniper, you have to log in and configure rate limits. And you do that to 60 routers, then that's not scalable. It's not really a feasible sort of solution. So we needed something else out there.
I just want to point out to everybody that you don't need a specific router to do your black hole. You don't need a special. I mean, you need a machine that does it, but it doesn't need to be a specific job with only black holing. One of our black hole route servers pushes a gig of traffic through it, live traffic through it a day. A gig a second. It's not CPU intensive. It's not going to suck the traffic to the box. It just needs to be a router. You don't. A lot of people will think that you need to buy some specific router to do this. You just need a router. You can put together a Linux box and put Zebra on it. I mean, that's pretty dirt cheap. And you do it.
And you may see the IDS solution vendor round up with all these different IDS vendors out there, Arbor, Asta, and those guys. And me, wearing my Cisco hat, working with them, trying to teach them some of the techniques. They were all asking me, how can we do, where we automatically put ACLs everywhere on the network? And I was going like, go away, no, do this, right? Go out there and you got your IDS tool and get Zebra or Gate B, you choose, free routing protocol code on your Unix box. And then you can create some sort of tool where you can tell your NOC guy, here's an attack profile, and press this button to remotely trigger a black hole, and out it goes, right? So fire up a Linux box with Zebra or Gate D on it. Use one of these little 3600s. Use a production router. The infrastructure you need to do this sort of technique is there's no excuse. There's no excuse for not being able to do this sort of technique.
I forgot to we actually answered questions. Sometimes I wander, so you have to answer questions.
Okay. So any more questions on remotely triggered black hole and black hole? Here's a little graphic, shows you what to do. It's a little bit bucket. So that's kind of like the attractiveness of this technique because you can rapidly respond to it. And I've seen in working with our PCERT team, Cisco's Product Security Incident Response team, and when I get calls handed off to me, where we've seen attacks shift. So you get like a highly visible site and they start getting attacked, and then they put a counter up. Like for instance, one attack, they were getting attacked with one particular DDoS array, all spoofed addresses from a distributed denial of service attack array. And so they went up there and put an access list out to protect it, and then 5 minutes later, all the addresses changed. Okay, all the spoofed addresses they put the access list on, they're all changed, right? So apparently the guy who was launching an attack was watching the effectiveness of the attack. Right, saw that the attack was getting countered and shifted his attack profile with different addresses. Right, so when you have attackers out there that have that sort of capability of monitoring the quality of the attack, then you need, logging into devices and putting defenses up there is not a feasible solution. You need something that you can just have one device in your network and just go, okay, here's this drop list, and if it shifts, then you just log in and say, okay, here's the next one. And be able to respond quickly to it. So that's one of the big appeals to this remotely triggered black hole technique. So, some of the gotchas. This is kind of like I was bringing up with them because they got all modern equipment. But the defeat a myth that I hear every now and then. Back in the days of when this was running the internet, I don't know if anybody remember this box. People too young for that. All the drops to null zero was process switched in Cisco. So people said, oh, never put, black hole to null zero, do black hole to loopback. Well, that's ended. That's been for years, for half a decade, where it was a fast drop technique. But still, this was also a box just like these 3600s and the Engine Zeros and the GSRs and some of the switching devices out there with some of the the other switching devices out there. They're what we call software-based forwarding. In other words, you got a CPU, maybe a big fast CPU, but it's still a CPU, and you got general software that the packets are going through, and that general software is going through everything and doing the forwarding and doing the features and things like that. Bigger routers today, you have specific forwarding ASICs that are designed specifically to forward, all right? And there's a difference between them. The big difference is when you have software-based forwarding, you're never going to be able to drop that line rate because you have some CPU that's managing the software and you can never drop that line rate because that CPU is going to spike up at some point. When you have ASIC-based forwarding, whether it's the PSA chip on the GSR or the IP2 chip on the Juniper, those guys, when they drop, it's just a clock cycle. It's just clock drop, and they can drop that line rate, all right? So this is where knowing your equipment is really important, so you can know that if you have some sort of equipment in your network that's software-based forwarding, there's no specific ASIC, you got to know that you're never going to be able to drop that line rate. Where if you have some sort of ASIC-based forwarding device in there, you say, okay, I can drop that line rate, all right? Now, one of the things that came up this summer with Code Red was we had some guys out there who were, they had routers out there that were advertising default, all right? Now, I don't know how many of you, looked at the attack profile of Code Red. The Code Red would go out there and, most of the addresses it was trying to log into and scan were junk, unallocated junk, right? Now, any router out there that's advertising default, where is the Code Red going to go? It's going to go to that router advertising default. And so you have these guys with software-based forwarding engines, and they're advertising default, and they're getting slammed with Code Red traffic, right? That's just dropping, and it couldn't handle it. The CPU is climbing through the roof. So I said, why don't you put some sort of shunt, right? Because in the AGS days, what we used to do is we used to do this little technique where instead of you can forward packets faster than you can drop packets. So what you do is you stick a Ethernet AUI cable with a T connector on it and put a static MAC address on it and a static route going to the static MAC. And that T connector will get nice and red when you start forwarding packets out to the little T connector. And it worked quite effectively. But see, this was an old technique. So this summer you run into, I said, it's a pause world. I said, well, we kind of dusted off this technique. This is where knowing these kind of bags of tools, these techniques came in. So here was a technique we used maybe 10 years ago, and then this summer all of a sudden the need came up to use that same technique updated, where we just take a pause connector and back-to-back connect them, and you can spoof it where it looks like it's on, and you're passing packets over to the fiber, and the fiber grows red because you're taking all the Code Red traffic and you send it off to a spoofed fiber because you can forward faster on software-based forwarding than you can drop, right? So this is where knowing your equipment and knowing some of the techniques that work well with your equipment come in handy, and also knowing some of the techniques that worked maybe 10 years ago, you can still reuse and reuse it today. So that's the black hole shunt technique. So sinkhole route server.
So, okay. So
this is what we're building to. You want to do this?
This is the last.
Right. No, yeah, I'll do it sometime.
Yeah.
The slides. So the sinkhole is what we're building to as one of the techniques we're talking about. Where here you got a target. Here's a guy who's getting attacked across your network. So he's getting attacked, right? And it's that host server down there, 172.168.20.20.1. He's the guy getting attacked. Now, one of the things I'd run into is I ran into some customers says, well, we don't do anything because that aggregation router is a box with a whole bunch of channelized OC12s, and we got thousands of customers in that box, and we don't want to do anything on that box. And that's a valid point because that's a risk assessment you have to make. We don't want to do anything on that box to classify, to do it because you are responsible for all your customers, not just that one customer. But there are things you can do. This is where the sinkhole comes in. You prepare. You have a network that you can blow up. We talk about basically a sinkhole network is a network you can blow up. So here you can throw an advertisement on that particular route and you advertise that prefix is going to attack, that host is going to attack, you advertise it. So what happens is the attacker's traffic gets redirected to that network designed and ready to blow up. All right? Now, hopefully you can put it into your network in such a way where you can take the attack profile, so you can do things with it. So this is basically what a sinkhole network does. Is it sucks traffic over, and you can do things with it and watch it. So you pull an attack off the aggregation router, so you can do things with that. So you can work the attack. You can do classification. You can do flow analysis. You can put sniffers. You can do tracebacks. You can do all sorts of things. The key thing with this technique is it minimizes the effect, the risk to your network. If you have these big aggregation boxes, you can pull it off to a sinkhole where there's less of a risk as you start putting in classification ACLs and things like that. And what some people also do is you can advertise default from this point. For Code Red and NIMDA, this was a technique. This is a technique. I used this technique back in our military network back in 1990 during the Gulf War when we had some attacks on some of the military networks. So this is this technique has been out there for quite a while. But Code Red, especially, I was calling up working with ISPs, and they were getting Code Red all over the place, and I was saying, like, do one of these and have it go through the router and have one of these Apache tools that will log all the Code Red violators, so you can see who the culprits out there and start stomping out Code Red. And so this is a technique a lot of different ISPs started using just because of the Code Red, because it worked effectively for that. So how about you guys' experience with this? Because you guys use this quite a lot.
Actually, yeah, this was confuse myself. This is our lab network, basically.
Right.
It's our single network. And like Barry said, you can route individual IP/32, anybody's network space we can route down to this lab, and we can look at what the attack is or what their customer is doing or what have you with that router in the network. In the case of Code Red, some people asked us, can you get us a list of people on your network that's Code Red infected? And we said, well, everybody on our network either default routes up to us, and then we have to figure out where to send it, or basically the default router they use BGP to get onto our network. So the problem is, how can we find out all the customers and all the dial people that dial in our network or your network that have these problems? We advertise the default route, and we put up a route for a /3, 96/3, which is all unallocated. Hopefully it's all unallocated. So we have this route, we have the /3 network. It would go to this, what's this name? And we route this down into our lab. And then in my case, I routed it to a Netra box and just TCP dumped it and started watching for traffic. And at the height of Code Red and NIMDA, we were getting between 30 and 50,000 packets per second of nothing but TCP port 80 SIMs from all over. We were able to identify a couple 100,000 machines that were infected in that way. If you send the default route down, you get everybody's garbage traffic off the internet. And it's kind of, in a way, interesting to see. You can also catch people on your network that are getting attacked as the responses go back to the spoofed addresses that don't exist. You catch all that traffic. So it can be an interesting tool. You can run an IDS on it and try and figure out which of your customers is under attack. Okay. So, yeah, it is.
Yeah.
Yeah, it is a lot like pulling in all the garbage of the internet, the garbage collection point.
You want to be careful though.
Yeah, you have to be careful. Again, at the height of Code Red and NIMDA, we were getting
300,000 packets.
For just Code Red and NIMDA, we're getting about 30 to 50,000 packets a second. For everything else, we were getting close to 350 or 380,000 packets per second.
So you better have a pretty decent edge router, or else you're gonna destroy it.
Yeah, our edge device is not very happy. We actually got a call from the NOC saying, "What are you doing? Please make it stop." So you have to be friends with your NOC too, unless you're in the NOC in this case. Just be friends with yourself. So we don't work on the NOC, so
Okay.
it'd be nice to come all the time.
We're going to take a quick pause so they can switch the tapes. Implementing these. Again, you look out.
I think I could use that.
Okay. Yeah, maybe. So look at how you put these into your network. You want to, again, the sinkhole network should be a network that can melt down and not affect any of your network operations. So it's also a network integration exercise to see which parts of the network where you can plug this thing in so you can have your network operate. But it's also a very useful tool in the sense that you can see a lot of stuff that's happening out there. And also, as you see, like tomorrow, we'll have some more IDS vendors up there. The last couple of weeks, we've been having IDS vendors come up. The last couple of NANOGs, we've been having IDS vendors come up and present their ideas and technologies and things like that. And they're probably all out there with you guys saying, oh, wow, this is a great tool. How can we plug it into your network? And a sinkhole is a good way to kind of like check out their tool, because you go in there on your network and you advertise default on your network into your sinkhole, and you're going to suck in all the garbage. And with some networks, I know with these guys' networks at WorldCom, when they advertise default, they're not always sucking in their garbage, they're sucking in other people's garbage who are defaulting to them. So they're in a very interesting situation, because they'll have providers who will default into UUNet, and then all that garbage goes into UUNet.
Ad providers shouldn't do that.
Yeah, and so you have this, they're like a garbage collection point, it all goes in. So this is a good technique to check out these IDS vendors. Next technique, I'm handing off to these guys. Backscatter traceback technique. The classification UCL, black hole filtering, and remotely triggered black hole filtering, and then a sinkhole. These are three techniques all built in to what these two guys did to work on how do we trace back, how do we figure out where the attack is coming from really, really quick. So I'm going to hand this next part over to these guys, because there's a technique they came up with in putting these pieces together, right, and coming up with a technique. And then we'll have a demo of it that will.
We'll do the demo. We'll do the demo after break. Because
right.
How long do we have? 10 minutes? 20 minutes? 30 minutes? Half hour. There we go.
Yes, half an hour from break. Okay, so backscatter traceback.
I'm Brian, by the way. So I guess we designed or fell into or got lucky, right place at the right time. This technique that we use. It's actually a combination of multiple things. It's a combination of black hole route server, it's a combination of ICMP unreachables, BGP usage or effective uses of BGP to make our job easier. Our main problem is we don't want to go across every backbone router when we trace an attack, and if it's distributed, we don't want to have to go back 15 times. That makes our life difficult. So the goal was to make it fast. We did 2 attacks on Thursday before we or Friday before we left, and each one took about 2 minutes to track. So I guess that's better than 8 hours. So here's how it works. What we do is
this is just so everybody knows what backscatter is.
Right.
Yeah. So.
Okay. So the backscatter is when you get a packet that goes to your null 0 on your Cisco or your reject interface on your Juniper, or I don't know what they call them, Foundries and everything else, I apologize, but whatever your bit bucket per se, if it is a proper router and it does conform to RFC, it should generate back a host unreachable or network unreachable or something similar to that, depending on if it's a host that's null routed, if it's a network that's null routed, it should give some kind of unreachable back. Okay, so that's a basic principle of backscatter for what we're using it as. We're looking for those ICMP unreachable messages that we're getting back. Okay, so what we do is we have our sinkhole network, which we advertise 96/3 at all times, and we no export it so nobody else gets it. It's irrelevant what you use. You can change the net block if you have to vary your technique for what you need to look for at the time. And I'll explain that a little bit more, but the basic idea is you're advertising out junk blocks that traffic should never originate from. You should never see traffic from 127.0.0.1 on your network, right? Because that's a loopback block. It just shouldn't be out there. So the idea is you're looking for stuff that you know is bad, and you want to get this traffic back. and effectively figure out where it's coming from. So your sinkhole router and your sinkhole network sits there, and you advertise out these junk blocks, okay? And then so a customer calls in, okay, this is the black hole route server again,
Right.
more or less, which is an integral part of the thing, and I'll explain how it works here in a minute. So what you do is you have your customer call and say, I'm under attack, and I'm under a SYN flood, or I'm under an ICMP flood, or it's irrelevant. I'm under some crazy new flood that I've never seen before. And so you have to classify the traffic and figure out where it's coming from. So the first thing you want to look for is is this traffic coming from my junk blocks that I've advertised out? And if not, what do I need to do to get it to fall into a junk route block that I'm looking for? Attacks nowadays are going to fall into 5 categories. They're going to be randomly spoofed from all over the internet, randomly spoofed from a Class A, randomly spoofed from a Class B, randomly spoofed from a Class C, or just not spoofed at all. Or they're going to be some kind of Smurf attack or amplification-based attack, which you can use the same technique to track too. But let's forget about the amplification attacks. So you have 5 categories that the attack can fall into. Does everybody agree with that? Yes, no? Okay. So you need to hone your technique at the time. If you have somebody that's spoofing out only a Class A, you want your sinkhole network to be that Class A. So if it's coming from 216/8, that Class A, you can effectively push out a 216/8 route to your backbone or your network and still have everything work correctly and get the junk traffic back. So all the more specifics in the routing table are always going to get sucked, are always going to get used. So you push out this big aggregate block and say, anything that doesn't fall into a more specific block gets sucked into my sinkhole block, my sinkhole network. So if it's getting sucked into your sinkhole network, there is no route out there for it. So it's invalid. Theoretically, it should be invalid unless somebody bounced, but that's something irrelevant. That's something different. So the thing is, you can hone your technique. You don't have to look for 96. You don't have to look for 97. If it's coming from 210, you can look for 210. So the thing is, we use 96/3 in these for example, because that's what we use typically. But it's not a be-all end-to-end-all solution. You've got to think out of the box. You've got to think, what can I do to get traffic that's not supposed to be out there into the sinkhole network so I can see where it's coming from. That's the basic idea. So you have this sinkhole network that's advertising this 98 or 96/3. So you have a customer, they call and they say, I'm under attack and I'm under a SYN flood. So you put up an access list on your edge device and you say, I want to deny any traffic coming from the 96/3 network, because it shouldn't be coming from there in the first place. And you say, okay, I'm getting matches. So there is junk traffic flowing into his network. Okay, so now I want to figure out where that junk traffic is coming from. Now you can track it back by hand if you really want to. If you're a glutton for punishment, I guess you can do that. So this is where the black hole route server comes in. You push out your black hole route. And so you push out for the victim IP address, the black hole route. So now effectively all your edge devices are becoming a sniffer for you. Okay, you're making all of your edge devices a sniffer even though they don't know they're doing it. So all the traffic comes into your network and gets dropped, which is this right here. Okay, so the side effect, and you're going to be looking for unreachables because the host that you null routed is unreachable now, correct? So the router should be generating some form of ICMP unreachables from that router back to the source address of the packet saying, this host is unreachable, stop sending me packets. Okay? So this is what you're looking for. You're going to log this traffic. So the traffic converges into your network. As soon as it comes into your network, it gets dropped immediately because it says, this host is unreachable, right? And the SYN flood is coming from 96.1.1.1, right? So it comes into your network and it says 96.1.1.1. Your edge device is going to say, hey, I need to send an unreachable back to 96.1.1.1 saying, this host is unreachable, stop sending me traffic. But there is no 96.1.1.1 because it's spoofed traffic. But if you have your sinkhole network built correctly and you have your 96/3 advertised, now all of a sudden you do have a route for this 96.1.1.1. And it comes back into your sinkhole network and it's unreachable. And guess where it's sourced from? It's sourced from the very first point in your network. So you just figured out where the traffic's coming from instantly. if you, whatever the other end of the /30 that it just came back from is your customer that you're looking for. You know, it's as easy then as trace routing across your network to see where that IP address is, getting on that router, showing the IP route on the router and saying, hey, this is the customer.
So how much traffic comes back to central network?
Okay, the question was how much traffic comes back to the single network. It depends on how big of a block you advertise. It depends on how many attack points there are. It depends on the settings you have on your route. I mean, if you have a Juniper or a Cisco that you've rate limited down ICMP and reachables from all your edge devices to 1 every 10 seconds or something like that, then you're going to get 1 every 10 seconds from each one of your edge devices that the traffic's traversing. So you can't really tell. I mean, like I said, you have another problem of you have just junk traffic flowing across your network every day. You just don't know about it, mate. You know, we never knew about it. We didn't know how much junk traffic just flew across our network all the time. So when you put this block up, you're going to start sucking traffic down to your sinkhole network, even if you're not tracing a path. I mean, depending on I know NIMDA shot our traffic up on our line by 80,000 packets a second before we even knew it was happening. So it's something, you know, I mean, it's something you got to take into perspective when you build the network. I mean, we have, like he said, we have an OC12. I know not everybody else can have an OC12 in the lab. It would be a perfect world if we could. I mean, I think typically a DS3 is probably fine or something like that. And even, you know, to some point, you don't even care to get the traffic, right? I mean, you don't necessarily need to get that traffic. You just need to get the traffic down to the pipe so you can drop it or look at it and log it, more or less. So you can just punt traffic out to your cascade switch and have your cascade switch drop it. I mean, there's lots of alternatives. You can just get a T1. You can build a fake PVC on an ATM uplink. I mean, you could do all kinds of stuff. There's multiple ways to do it. So this is what happens when you black hole. You get back all these, you get these hosts and reachables back from the very first ingress point to your network, and from all the ingress points on your network at once, back to your junk block, because these blocks don't exist except you're advertising. So you're getting this traffic back. You're basically sucking in traffic that shouldn't even be there. So you're making your routers do things that they're not supposed to do, but it works. So here's an attack where somebody's just flooding from the 96/8. There's SIM flooding. That's a fake block, shouldn't be used, it's not allocated to anybody, so the traffic can't be real, right? It's got to be attack traffic. So that's where the classification part comes in. So if you were to get on your router and do a show IP route to 171.68.66.18, if that's part of a /30 to your customer, it's going to say, this customer's DS3, or this customer's T1, or this customer's OC3, because that's what, that's your line that you have in there. So, question?
But in practice, how do attacks actually use and just one and not the client? Suppose every one client and keeping track of the client or part of the population.
Yeah, the question was, attacks use blocks that aren't assigned. Yeah, typically, I mean.
Said how many?
Oh, how many attacks?
A very large percentage.
90%.
People are lazy. They just
Right.
download sync4.c and say, I hate you, sync4.c your ass.
And you got to realize, sync4 is a pretty lame tool. It takes 4 octets and generates, or it takes 4 blocks and takes 0 to 255 and randomly generates a number and puts that together as a 4 octet block and shoots it onto the interface. That's all it does. I can come down there if you want. Here, I'll come
Because we
down.
got it on tape, yeah. So we can. So if you have we welcome long comments and observations. So if you have long comments and observations from your experience, we'll hand you the mic.
I promise I won't sing. One comment. I did a study of a site we host, and 68% of what hit that site were bogons. So they were spoofed addresses. However, that leaves a small percentage that weren't. If you look at most of the botnets that are out there, if you're familiar with IRC botnets, they don't bother to spoof. There's no need, right? Because there's so many of them, and the torrent that they generate is so heavy, they don't really care if you get 50% of their bots, right? They're just going to go to their next botnet and get you that way. So I'd be very cautious about making statements. And I think, Barry, you had said, you know, oh, if you block all bogons, you're safe. That's not true. I agree with that. It helps, but it's not the end-all, be-all. So, just a thought.
A good point to keep in mind is if you black hole networks, the test network and all this other business, it's not going to help you in this case. Because if you just black hole it, all you're going to do is dump all traffic that's destined to that address, not stuff sourced from that address. So if you block the 10 network on your backbone, whoever you may be, I can flood from the 10 network, and your black hole isn't going to help it. Okay? Because the destination for my flood is still whoever's on your network. So your routers will happily route that traffic directly to the customer. Now, when they send responses back to the 10 network, those will happily get dropped, but it's too late. The customer is already dead. So black holing that and not accepting those routes, yay, terrific. Doesn't help the problem. It doesn't help you track an attack. It doesn't help you stop an attack.
And what he said, I'm sorry, I didn't catch your name. What Rob Tom said is true. I mean, you have to, like I said, you can classify attacks into, you know, different realms. They're fully spoofed or not fully spoofed. They're not spoofed at all. In a case of a botnet, they're just dumb Windows boxes that UDP flood, but it's also very effective, you know. So that's what I'm saying. You can't just, nothing's a be-all to end-all. It's never going to happen. It's just never going to happen because there's always, somebody's going to come up with a new technique to go around what the be-all to end-all is. So you got to, you know, take that into account when you're looking at stuff. You need to try to classify. You need to figure out what's going on first. You need to not run around like a chicken with your head cut off when you first get the call, which people do. You know, I mean, you got to be calm about it. The internet, if it broke tomorrow, life will go on, and you know your customer will be mad. But the idea is to get them up, you know, as quickly as possible, and by going crazy and not thinking things through, not trying to figure out what's going on at the time is a bad idea. So you need to really effectively figure out what's going on initially, and then this technique, like I said, isn't perfect, but you can hone it to use it. You can hone the technique to use it for other situations. If it's spoofing out of Class A that you know nobody owns that whole Class A, you can look for traffic, that junk traffic from that Class A, and try to suck it back into your network, you know, and try to figure out where it's coming from. We've had to do that a couple times. So, I mean, there's ways to get around it. And if you have somebody that's spoofing Class C, as long as they're not spoofing somebody else's Class C, which is very rare, they're typically spoofing their Class C, that's the easiest trace routing back to the network and, you know, stopping them. But they're not very smart, so. And then again, I guess.
Okay, demo time.
We'll do this when we get back. Or do we have time now?
So see what time's the break?
10.
It's 10 till right now.
Back at 3. Is that what the break is?
Break is
From 3 to 3:30.
yeah.
No.
So any more what we'll do is we'll do the demo right after the break, and so we have the demo all set up. Any more questions on this? I'm sure there's going to probably be several people come up here and ask questions. That's okay too.
Yeah, I'll answer anything
Okay.
you want to ask me if I can.
So we're taking, I guess we'll take 10 minutes early for the break, and we'll see you back here at 3:30, and we'll continue with the demonstration of this technique, so you can see it work in action, and then continue with the rest part of your network. Yes, I think Chris and Brian are emphasizing over and over again they have 2 OC12s going into their lab, which they use as their sinkhole network. So, you know,
T1 won't cut it.
T1 won't cut it in the UNet's case.
I mean, you don't have to necessarily, like I said, you don't even have to have, if you are, feedback again. If you're, you know, another mid-sized provider, big provider, and you don't want to even take the time to run the lines to your lab, you don't even have to do that. All you have to do is have a channelized OC3 or OC12 or DS3 or hits whatever you have for your aggregation points, and build some fake sub-interface that's on there and run it into your run it into your cascade switch or your whatever switch you use. It's irrelevant. Anyways, you run into your aggregation switch and just push the traffic across the switch just to have the switch drop it. Doesn't matter. I mean, obviously your aggregation router is going to take more traffic than before, but you don't need to actually funnel it through to a network to get some of the benefit out of it. Obviously, if you don't have it funneled through to a network, you can't redirect it to a box and TCP dump the traffic, but you gotta, if you can't, gotta get what you can.
Like Brian said, this could be dangerous. You're opening up Pandora's box. His point was it could screw up traffic engineering network by all of a sudden pulling 500 meg into your single network. So hopefully you're not just letting anybody in your company set this up. Hopefully it's being set up under proper supervision, whatever that may mean to you.
The main thing to point out here is think about what you do before you do.
Well, another caveat on it is, say, like a lot of different ISPs are starting to set up security teams. This is where it's important to make sure your security team understands what a routing protocol is, because I've talked to several security teams out there, and all they can think about is firewalls, right? And they know firewalls very well, right? And I start talking about border gateway protocol and OSPF and ISIS. They go, "What's that?" So again, make sure you got the correct skill set working on this. This may be some sort of technique that has to be embedded in your network operations team, because that's the people who has the BGP skill set to understand this. So, demo time. This is kind of like our demo network that Brian and Chris pulled together. So I guess you want to explain what we got.
He's going to attack from his Linux box to the target, which doesn't exist, but it's irrelevant. The traffic's going to flow from one edge to the other edge, and we're going to show you how we can track it by just injecting a black hole and having this stuff set up correctly, the 96 block. We're going to use a regular old Sync4 SYN flutter, which is going to be what every kid uses out there. It's going to be what you see in the real world, more or less. So there's not a drawing here, but off the same router that the target's off of, there's actually an Ethernet link that we routed out the 96 block out, the 96/3 out. So that's where we're going to catch the unreachables once we black hole the IP address that's getting attacked. So, just plug in yours. You want to start, or whatever. Okay, you know what? Just plug into mine. All right, so I'm on the edge router that's going to have the customers getting attacked here. What are you doing? You have to hold. There you go.
All right.
Start going.
Well, first, okay. So on the
But we're not going to show statistics yet.
right. Well, no traffic, right? All right. So that should be this guy with no traffic. And if we basically on the far end destination, which is the other router which we can't get to right now. Anyway. And we should see some traffic, hopefully.
Yeah, the up arrow doesn't work on Windows terminal.
Excellent.
Way to go, Microsoft. So we're starting to see some traffic, a whopping 8 packets a second. Laptops make great flutters, let me tell you.
It's a lot better normally.
Well,
I mean, so I've heard.
all right, so it doesn't matter. We got a flow of traffic. Okay, so there's a flow of traffic. That's all junk traffic. So what we're going to do is we're going to telnet to the black hole route server here, and we're going to actually inject the route. Why don't you just do it from here?
Easier, huh?
Do you want to get... Did you keep that flow going?
Yeah, it's still going.
Here. Flip it over. So he's consoled into the... There we go. Black hole route server that we had. So the flow's still going. Hold it down for a little bit. One more.
Well, I can't do both that, but what's
Yeah,
in
you
there?
can.
Anyway, so we should just do this too. this is the black hole router with the same configuration we had up earlier. Right? It's running a BGP process. It's got IBGP mesh with the rest of the network. It has a local route. Wow, is that flickering? To null zero for the black hole route, which is the same route that's on every other router in our little network here. And the route map for static BGP says, don't set out the black hole route, and then match anything with tag 666 and send that to with a special vector. So we'll. Oh boy. Yeah, we're doing this over the wireless network. So who owns this block that's getting attacked? No, we're not. So I should be attacking. We'll flip this here.
I thought you were attacking 0.1.
All right.
0.1.
So 0.1 is currently getting attacked with my crappy little laptop. And up over here.
You're black on the wrong IP.
Oh, 0.1. Hey, mine is very That's what you were saying.
Yeah, you're black on the wrong IP. So this is a guy getting attacked. So what we're going to do is we're going to black hole it. Normally when you have a customer, you only have to black hole it for a minute, 45 seconds to a minute. So they only see a drop in traffic for 45 seconds to a minute, which for everybody I've ever talked to is acceptable to figure out who the kid is that's doing it. And here we go. And we're going to start getting floods here. So, all right. So I'll show you that. See the access list above it? That's what's applied to the interface that has a 96 block routed to it. So as soon as we black hole it, here come the ICMP unreachables back from the interface that he's plugged into on the one edge device with the destination address of the junk that he's generating. So that's what's happening. The traffic's coming into our network. We're black holing it. We're sending an unreachable back to the source address, but the source address is spoofed, so it's junk traffic. It fits into this 96/3 block, so that we've routed down to our sinkhole network, and we're gonna start looking for these unreachables with this simple access list that just says, permit ICMP any. Well, this is, permit ICMP any host unreachable, whatever you want to do it. You can do it 1,001 different ways. So you're seeing this traffic coming in. We're seeing it going back from these spoofed addresses, and we say, okay, it looks like 172.16.20.254 is where it's coming in, and his machine address is 172.16.20.1. So he's on that /24 that the interface is on. I wonder if we're going to actually have the console and to get to that router, so we will. And so what we'll do is, you just put up the access list, okay?
Yeah.
But basically what we're doing is we're flooding across our backbone, so I'm going to plug him into the other edge of the backbone, which is what he's plugged into. Ethernet 00 is where the sources of the ICMP are coming through, and there's the traffic. And all you have to do at that point in time when you find out you want to drop the traffic on the ingress point to your network, so you drop the traffic, you just build a basic access list that says, access list 100, deny IP from any to hosts, whatever the host is that's getting attacked, and then permit IP any. And now we've dropped traffic from the attacker to the attackee from that network only, and everything else goes through the network, and everybody else on the internet can go back to seeing, CNN.com or eBay.com or whoever was under attack at the time. And there you go. There's a flood. So instead of having to go from edge device to core device to core device to edge device, we went from edge device, black holed, looked for the traffic to our sinkhole network, and now presto changeo, we've just dropped out 3 hops that we don't have to hand trace through and possibly crash the router, or more than likely crash the router if it's a big flood. So the idea is we're minimizing the impact on our network.
Back over to the other one.
And we're not getting these unreachables anymore. Or shit, that's probably throttled. What's that? Well, the traffic never really, the question was, do you ever put up access lists in your black hole routers to see how much traffic's coming to the black hole router when you black hole the traffic? Right, yeah, exactly. You're saying, well, I mean, basically what's going to happen is you're going to go from pretty much getting nothing to all of a sudden you're going to get, you know, this one IP address is just pummeling back your sinkhole with all these unreachables. And you say, you know, this wasn't there 20 seconds ago. I put the black hole route in. Now all of a sudden I'm getting all these messages back. You know, who's doing it? And this is the guy who's doing it. I mean, sometimes it's coming from one place. Sometimes it's coming from 5 places. And the great thing about it is you're going to have every single place at once. You don't have to track it back 5 times. If it's distributed, it's done. You know, you just go back. You just go to those 5 places and drop it. But on a typical attack, you know, everybody gets all worried and worked up that there's these huge DDoS attacks and all this stuff. We don't see that. It's
the worst thing is botnets.
Right, but it comes down to it's some kid that took over some box in China and goes through some Chinese ISP that has 2 OC3s, and then it comes across and we see the traffic's across 2 OC3s, or a T1 or a DS3 customer. I mean, we've never tracked an attack like this. Well, there was one attack that we saw that was 500,000 packets a second, and that was as bad as I said. Yeah, it was really bad. What's that? Yes, definitely. Yeah, the question was most of the attacks take out the customer's infrastructure instead of our infrastructure. We've never had an attack take out our infrastructure, say February 2000. But since then we haven't had it happen. So, thank God. Knock on wood. Hopefully it won't happen. But another problem is that you have customers that just, you know, it's not their fault, but they just don't know, you know. They've had people get laid off that knew, and they couldn't afford the salaries anymore. Now you got some guy who doesn't know, and he just knows those routers bouncing up and down for the past 5 hours. He doesn't know that he's, you know, transiting an attack. So it happens a lot. But so there it is. One hop, or you don't even have to go a hop. You go right to the edge device, and you know the reason that we've gone to great lengths to figure out how to do this is because we don't want to crash core routers. We don't want to crash transit routers. If we crash transit routers, then we have a you know, our backbone impacting problem that affects more than just the customer getting attacked. Now we've affected thousands or tens of thousands of customers. And if you're doing it for a dial-up and you knock out some dial hub, you've, you know, done it for 100,000 customers. You know, can't have that happen. So the idea is to get off the routers as much as you can and focus on the edge.
No, one of the key things to kind of take away from this, because it's been talked about in many different NANOGs and IETFs, is there's been, you know, say like, you know, most of the attacks like that Brian and Chris are seeing are single host sort of attacks, maybe a few hosts, but a lot of people are getting paranoid about distributed denial of service attacks where you got coming in from many different entry points. This backscatter traceback technique, you know, works on their network infrastructure where you have, you know, what, 60 to 100 to I don't know how many ingress points, exchange points, private peering connections.
We've got 2,000 routers.
Yeah. So, you know, so the equation where you have all these different entry points where the attack would come into their infrastructure, this technique works for that. So if you have multiple distributed denial of service attacks, this technique would be able to identify the entry points coming into their network. The other thing, and I think the key thing why when the three of us talked about how to present this here that we get at is this is where they can do it to the edge of their network, but then what, right? And we've all talked about with different presentations and techniques and different protocol ideas and, you know, the iTrace idea of how to go back to the source. How do we get to the culprit? Well, and especially when you have a source address. Well, if you have multiple ISPs using this technique, and we're talking about being able to do a traceback, you know, in 5 to 10 minutes, it's a NOC coordination issue. It's one ISP tracing back to their ingress point, to a private peering connection. They call up that ISP, and while they're on the phone, they trace back to the next point, and then you go to the next guy, conference them in, and you go to the next point, right? So if you have multiple ISPs with this capability of doing this, you feasibly, because you're talking about 5-10 minutes to do a traceback across a big network, can get down to the source, to get down to the culprit who's actually launching these attacks. And we're not talking about adding any new protocols, not talking about any new feature capability inside your network infrastructure. We're not talking about any new equipment. We're talking about things that can be operationally deployable. It's just an engineering equation of designing this tool into your network.
And we're not the only one that does it now. I mean, since we have shared it with other providers do it. So it's not if we can do it, they can do it, you guys can do it. It doesn't have to be on the biggest scale, obviously. Everybody has a different size network, but the basic principle behind it is scalable for any kind of network you have, or we hope it is. And if not, tell me and I'll try to make it as scalable as I can for you guys. We would much rather have the problem go away. And I mean, we're willing to do whatever we have to do to make the problem go away. I would love to be put out of that part of my job. I have a lot of other things I'd rather do than, handle attacks every day. So we're open to suggestions at any point in time. And our email addresses are on these slides. Don't hesitate to email us and ask us questions. We won't bite you. We'll answer as much as we can. I don't really think of myself as a teacher. I'm not really good at that. But if you ask me a question, I can answer it. If I know how to answer it, I'll give you the answer. If that I think's right, at least. So, okay. Are there any questions on that whole thing?
All right. Okay, let's go down. Next point. Now, the rest of the point, we're going to digress into some of the phases that we're seeing. So we kind of reemphasize these points. Now that you see these four major techniques and how the first three kind of reinforce with this backscatter technique, we can look at the 5 phases of working an attack. Key, number one, be prepared. And this is as one of my jobs in Cisco is you'll have a major security incident on the internet, and I'm one of the guys who actually go in there and post-mortem. So I call up the ISP, to call up the NOCs and say what happened, and I call up the guys who got hit, what happened, and what happened to the equipment. I got labs set up, I go through and simulate the attack and things like that. And one of the key things I've noticed is the dramatic lack of preparation. Dramatic lack of preparation that we got within us, the community, ISP community, where people haven't really been thinking about how to work the attacks and not really prepared to do this. So if you know you're going to be attacked and it's a matter of how often, then you should spend the extra amount of time to be prepared for the attack, to be able to work it. And this is not rocket science sort of thing, all right? Now, it's kind of hard for me to understand because I came out of the military side of the internet. I was 10 years in the Air Force and Milnet, ARPANET, DISA, and all that stuff. And on the military side of the internet, you make your plan, and you test your plan, and you validate your plan, and you drill. And you go through reaction plans where you go through and say, okay, here's my security reaction plan, and we got an exercise. We got a war game exercise. And one of the first things you do, you check your equipment, you make sure all your tools are in place, and you open the book and all your contact numbers, you call them up, make sure all the contact numbers work, make sure you can reach everything, your lines of communications are open, it's okay, and it's drilled into me over and over again. And then I go to an ISP and I say, okay, they complain, we traced this attack to this other ISP and we can't find a number to that other ISP. I say, you got a private peer connection with these guys, right? I said, yes. You can't call over to them. You don't have a number to call somebody who can do an access list on a router. Says yes. I said, well, what do you use as a reference? Oh, we use Gerard Marsh's list of NOC contacts. And I go, okay. Well, what if you have a internet critical BG-wide outage and you can't reach Gerard Marsh's website? What are you going to do when you're dependent on a web page and some of the ISP for your NOC to NOC contact list? I mean, it's as simple as that, where you as ISPs, in my personal humble opinion, should have the responsibility to have something simple like, here's my private peers, here's my ISPs, and here's my phone numbers and this is preparation. This is not, this is not, no BG, this is just, you know, very simple sort of stuff. Yes?
Ever run into the situation where you call a NOC and they have a hell of a time trying to even find out what circuit you're talking about?
Every time.
Oh, every time.
Every single time.
Yeah.
Almost every single time. The
Yes.
biggest problem from operations perspective with this is we'll be up at, you know, 2 in the morning or whatever, because I don't sleep until later, and I'll get an attack call, so we'll deal with it, and we'll call up, you know, provider A, whoever that may be. And I get some NOC guy who, maybe it's not his job to do security stuff, but his response is, send an email to abuse. Right? Well, that's great. I would send an email to abuse if it wasn't critical, but right now your peering connection with me is toast. So you really ought to get somebody from security. Well, we don't have anybody from security. Why don't you guys have a 24/7 security contact? I don't know. I mean, we do. How come you can't? You know, there should be somebody in your organization that's a 24/7 contact or a group of somebody. You know, 6 or 8 people who know how to deal with the problem and can be paged at 3 in the morning. Right?
Obviously, if you're big, you should at least. I mean,
Well,
you
even
should theoretically have it anywhere.
Top ISP, you really ought to have a 24/7 contact fee because it's going to affect you.
yeah,
It's going to affect all of your customers.
even small operations. I mean, this is take like my past life before Cisco was running Singapore Telecom, and in 1994 when I started at Singapore Telecom's ISP operations, I designated one of my engineers, and she was the security person. And for a year, she didn't do a lot, but I drilled her and trained her and sent her through, you know, Yukitori, red team, blue team exercises where she had a little attack network and different people in our NOC would take turns attacking the network, and we drilled her and drilled her and drilled her. And, you know, I got criticized by my management, my bosses saying, like, why isn't she doing anything? I'm going, like, well, she is. Well, about a year into the operations, the senior minister, godfather of Singapore, Mr. Lee Kuan Yew, the China-Taiwan incident was happening, and he was getting spoofed. His email address, somebody found out his email address and was spoofing him in Mandarin on the Taiwanese news groups, and it turned into an international incident. It was a big thing. Now, right then, there was my security person. It was an incident. She went into work and went into action and started tracing back and working with law enforcement authorities to work that back. Now, that was back in 1994, 95, of allocating staff to do that. And there should, you know, if you have a NOC, if you have operations, even if you're a small, medium-sized ISP, you should have people designated and security procedures in place to be able to handle when a phone call rings from another ISP to say, we have a security incident, we need to trace this back and work it. Okay? And if those of you who haven't paid attention, 2 days ago I posted an email notice out from a White House executive order, and because of the September 11th stuff, you're going to have more U.S. government people calling you up on the phone and say, we need to have this happen now. This is security. We need a line intercept, we need a wiretap. This is, I mean, if you haven't invested in the security team now, I mean, up to till now, you're going to have to. It's going to be a cost of operations. All right, so it's a normal part. Security, ISP security is a normal part of your operations team. You have to budget it, you have to plan for it, you have to make sure your staff is geared up to handle it, you have to drill it, you have to train it. You should, if you know you're going to get like attacked, you should train, you know, where you call your NOC, you call your own NOC and say, this is a simulated security event, this ISP's private peer connection is getting DOSed, it's saturated. And they should be able to, any of your NOC staff should be able to look up that circuit ID. They'd be able to work it back. They have procedures in place to know who to call, who to escalate, who didn't need to wake up at 2 o'clock in the morning. They should have that in place. You know, that's why I say the military knows how to do this. This is stuff that happens in the U.S. military all the time. They drill this over and over and over again. All right? So this is kind of like my, you know, my analogy after I talked through, especially after the February 2000 incident and did my postmortem and talked to a lot of different ISPs around the world, is that most NOC ISPs don't have security plans. They don't have the security procedures in place. They don't train on the tools. You know, it's all seat of their pants. Every incident is seat of their pants, case by case, and they relearn every time they do it. Right? Now, it's gotten better over the last 6 months. I think Code Red and NIMDA woke up a lot of people, all right, because it had dramatic impact the network so much. But if you don't do this, it's kind of like the, you know, equivalent to a fire department. You know, fire department runs out to a fire, and there's a fire, a house is burning down, and okay, here's my fire engine. What do I do? Okay. Yeah, the fire department doesn't do that. They train. They're also you can look at where they constantly train on these procedures and be ready for an emergency. So simple stuff. I mean, this is, it's a matter of just spending the time and sitting down and creating some sort of either an internal database, a file, or just a book with a grease pencil where you have the contacts of your peer connections, the circuit IDs, phone number of somebody you can contact on the other side of the NOC who can put an access list on or do a traceback command. I mean, this is stuff, and drill it, test it, stay like once a month, you go through all the numbers and all your peer connections and make sure all those numbers still work. Make sure that company hasn't gone out of business. Make sure that company hasn't been bought by somebody else, right? How this industry works, It's people buying everybody all the time. Document your policies. Some of the things I've run into is I ask ISPs is, okay, if a customer calls you up, what is and they're being attacked, what is your policy? Is it your policy to put an access list and drop the packets on their behalf or not to? And you should write these policies down so that everybody in your team will know, okay, if somebody calls up, we will not put an access list on to drop the packets on behalf of the customer because it's too risky for us. That's okay. It's okay to make that. That's your business decision you have to make. It's okay to do that, but you write it down so then everybody knows about it. Because if somebody who doesn't know the policy goes ahead and does it, then you have an inconsistent policy, right? So you write these things down so all your operations teams know this is what we do. Customer calls, they're under attack, this is what we do, okay? Prepare your tools beforehand. I mean, don't sit there in the middle of attack and then say, okay, I need to create my classification ACL now. Okay, let me dig up, Barry's ISP Essentials white paper and cut and paste off of that, to what it is. You should have these things ready to go. It's just, flat files on top of your PC that you can cut and paste in. Not rocket science here we're talking about. Scripts. If you need scripts created, you should create those scripts. Build your sinkholes and test your sinkholes and your backscatter. Make sure all work beforehand. And test them, test them. Have you tried these? This is where knowing your equipment is important. Like, for instance, I'll talk to in a minute. Like, for instance, what sort of equipment can you safely put classification ACLs without crashing the router? There's some equipment combinations that you can do it very easily. ASIC-based forwarding, some of the ASIC-based forwarding equipment out there, very easy to do that. There's others that are not. The others you never don't want to put it on, right? Have a policy of saying, like, if I have a aggregation router filled with channelized OC12 cards, says, okay, we should not put any classification ACL on that because it's too risky. Have those things done, simulate. And this red team, blue team exercises, right, is probably one of the quickest ways to get your security team up to speed, right? Whoever you train for security. If you have a little test network out there, get these guys and run simulated attacks. Where you designate a couple of people like, Chris would be the attacker and Brian would be the defender, and they train, they train, they practice, make sure they understand how the tools work and what sort of attacks out there. And this is kind of easy to do. You go out there and grab a bunch of the tools out there and, defender in there. Back in 1994, when I had the security person and she was going like, well, I don't know anything about security, I gave her a bunch of books. And then I took one of the guys from my operations team and says, okay, you're going to attack her this weekend. Here's her network. Your job is to take out her network, to do a denial of service attack on. The guy said, I don't know how to attack. I said, well, go to FRAC. Go to FRAC and download FRAC magazine. And so he was a German guy, and being very thorough and efficient, he downloaded all of the back issues of FRAC magazine. And so he had this big book about this thick of all the issues of FRAC magazine. And he opened up, and by page 2, he had taken out her network, right? and so he's going like, well, how do I attack? Well, there it is. There's your manual. The FRAC magazine is the place he started, and and she learned, and he learned, and she learned, and he learned, and they got really good really quick. Because one thing about security is it will really get you have to know TCP/IP, routing protocols, how routers work, how workstations work, really, really effectively, and it gets you up to speed really quick. Yep.
The worst thing you can do is not be prepared and put up a logging access list to classify and log 100,000 packets a second on your GSR or 50,000 packets a second on your 7500 or something like that, you're going to crash the router, and it's gone. And so unless you have console access to it, it's gone. You have to have somebody reboot it. So you want to look at, go get tools from the, Packet Storm. There's, Root Shell isn't as good anymore, but Packet Storm's good. There's some other sites I can't remember off the top of my head.
Just do a keyword search on
Syncflow or Syncflutter, or ICMP Flutter. You want to look and see, these are the tools that the kids are going to use. They rarely use something more than a generic program that they download from the internet and just go at it with. And if they do use something that's not generic, then you got a problem that you're going to have to take care of anyways, because if it's not generic and it hasn't been thought of yet, then you're going to have to figure out what it is and figure out what to do about it. So the worst thing you can do is not be prepared. And like I said, you put up something like a log input filter on a big SYN flood, you will crash your router. I don't care if it's a Cisco, a Juniper you can probably get by with, but it will have a detrimental effect on the Juniper even. You really need to take into account what it's going to be before it happens. The last thing you want to do is get in front of something while it's happening. It's going to be real bad and you not know, and it's like walking into an elevator shaft. It really is. It's like walking to an elevator shaft, never looking to see if there's an elevator there. That's pretty much the same effect you're going to have. So you really should take the time. It doesn't take a lot of time. It's not hard to set up a Linux box and download these scripts and run them. You yourself, you too can be a period/kitty in about a day. It's not a hard task. If the kids are doing it, you can do it too. You are smart people. You run networks, so.
Yeah. Okay, we'll take a quick pause so they can switch the tapes.
You've got on an interface, the ISP access room 170 out, waiting for time like 10 seconds, and IP access, no IP access room 170 out. If Cisco could get us a command that you could stick in there that would say thumb twiddle for 10 seconds, and then you do a config net on these, you could do a lot of these things a little bit more safely.
It's on the code and queue. So that's my primary job in Cisco, is to take security requests like that and get it into the code and queue. So
let's understand exactly what Brian means when he says the router will die, right? What he means by the router will die is not the router will reload.
Or just lock.
Okay. The router
get in, why not at all?
Right.
Sure. Okay. Sorry. The question was, The question was, you were actually kind of making a statement to Cisco, right? Pretty much, if you run a set of commands, and the specific example was you apply an access group to an interface, and then in various examples, wait 10 seconds and then unapply it. And would it be nice if Cisco had some kind of like commit and then rollback type scenario, kind of what Juniper does with the
commit request or commit and confirm.
Yeah, commit confirm kind of thing. That's kind of your question, right, or your state. It'd be nice to have a commit confirm type of scenario in Cisco, or apply and unapply it for a certain period of time. So when Brian says the router will reload, or it will die, it doesn't mean it will reload. And a reload on a backbone router is not a 5-minute event anyway. It's an hour-long event. So it doesn't actually reload. All you do is force the CPU on the router to do something other than pay attention to routing. When that happens, you drop your internal routing protocol. When you drop your internal routing protocol, you lose, at least our network, you lose all net hop information and your BGP table dumps. So now you have a router with no routes. So the router is dead. It's still up and running, but it's just not accessible to the world, and it's not passing traffic. So what Brian and I oftentimes say the router will die, what we really mean is that you'll lose routing on the box. And so your path to get to it across your huge network is no longer there.
You can get stuck with console.
Right, but I gave the current worst way of doing it, but it's better than dropping straight from off. If you do a reload in some number of minutes, but you will cancel if you can still get into it when your modification is successful.
Okay.
But it's a ticking time bomb that will reload you. I was saying, instead of doing that, they give you this one command. You do an active command that you're going to config that so it'll run totally on its own without you. And in the middle, says come to it in 10 seconds.
Right.
That's one thing is all you need is multiple.
For ideas like that, vendor specific, right after this meeting, if you got ideas, I got a pad of paper up here for the Cisco one, and I think there's supposed to be a Juniper guy here afterwards also, and so, you know, he'll stand over there, I'll stand over here, we'll take these notes for these ideas.
I mean, Juniper does, I mean,
You know.
I'm not trying to push vendors, because I don't do that, but Juniper does do that. I mean, they have a feature like that, so it's out there. Some people do that, some people don't. I mean, whatever, so.
Yeah.
Excuse me?
Right.
So, yeah, so the point was that the minimum interval on a Juniper is 1 minute. So you say commit confirm 1, or whatever the syntax is, just do a question mark at the end of Juniper. I can't command my help, just like everybody else.
Right.
So the minimum number you can put it is 1, so you can't do 10 seconds. Oftentimes, what we tell people when in our group when they do this is to have 2 windows open on the router. One that has the access list apply and one that has the no. And so as soon as you hit the apply, you move over and hit no. And your command will get to the router. And the router will go, ah, while it's trying to log, and then it'll take the command and it'll stop. So if you are really good and you get in just enough time, you'll be safe. You won't drop ISIS.
Right.
For us, it's ISIS. You could be OSPF or whatever.
Yeah, you know, the console that well, the one we want to do the no command should never be the console for it.
This is true.
Yeah,
Right.
it's a lot more helpful if it's
And you probably want to turn off logging
Yes.
console before.
No logging console. No logging console.
It's kind of a ghetto solution, I know, but it's the only one we have at this time. I mean, it's got, you know, right. Sometimes it takes that, so.
Yeah. I mean, but the point about knowing your equipment comes in with this too. You have to know that at 7,500, you cannot log a 5,000 packets per second flood. On a 12,000, you can log a bigger flood as long as you're not logging it off the GRP, and as long as you're willing to accept trace stack error messages in your log. Right? You probably won't kill a GSR if you log a 70,000 packet per second flood if it doesn't log the GRP. The GRP does all the routing decisions for all routing updates, right? So as long as you don't flood the GRP out,
Your line card
probably
might be
okay.
happy, though.
Line card
Might not be happy.
Yeah, it might be unhappy, but you have to be careful. You have to know your equipment. That's the whole point here.
Right.
Know your equipment and having something where Cisco's don't, to pick on Cisco, not really pick on, but where it doesn't immediately apply the configuration change when you type it in.
It'd be nice.
That would be nice too.
I mean, everybody's gotten bitten by that before, you know, no IP address, and oops, that was the, that's the IP address I just telnet it to. Darn. You know, everybody's, I'm sure, I've done that. I mean, I don't know, I'm sure everybody's operator's done that somewhere down the road. They've done some command that they didn't really think about the, you know, the outcome before they did it.
Yeah.
But, so the point is that you should test that stuff out beforehand, and so you know what you're looking at, and know what your routers can theoretically handle before you put up the filter, so you don't have a situation where you have to reload your router or turn it even, in an ideal world, you never even need the ticking time bomb because you'd know the threshold that you could do the filter on or whatever you're going to do on it, but it's not an ideal world, so.
Right.
I mean, to get around your example, that, again, what we tell our folks what we do is check the interface that you're going to apply the access on, make sure the packet rate is reasonable. Apply just a simple classification access list with no logging, just to see what kind of attack it is, because almost all the time the customer can't tell you, I wonder why that is. So the customer just can't tell you, well, I don't know, I'm just under attack. So you have to kind of figure it out with the customer what the problem is. So just no logging, just figure out what protocol it is, and then start stepping through, if it's something simple like a SYN flood, with a Smurf attack, or this or that kind, just block the traffic and not worry about, the nth degree solution.
Right.
Just block it and make the customer happy.
That first step of classification where you just do permits with no logs is important, because if you're watching counters and those counters are cranking up really high and you're looking at your interface and you're dropping on the interface, then right there you've done a classification step which says that the flood is so much that it's dropping on the interface, egress going out, and those counters are really cranking up. I don't want, in this particular box, I don't want to take a chance and do the log on this box. So this is where having in your bag of tricks, saying, okay, let's redirect the attack. Let's redirect this customer over to my sinkhole, and then do the log over on my sinkhole. Because if that one goes out, then okay, it's my sinkhole. It's designed to break. You're not breaking an aggregation router to supporting your customer. So this is where having your bag of tricks and doing a phase sort of classification, not just rushing in. Again, it's all preparation. It's preparation to have that option available to you as you see it. Because sometimes you could just do it on the aggregation router. Sometimes you want to move it off the aggregation router and do it off the aggregation router. It's case by case, scenario by scenario. But the preparation is key. There's also going through and audit your network configs. I mean, I don't know how many people have seen it, but when I first came into Cisco, I was appalled because this industry, this community, does a very, very poor job of documenting its lore, its experience, and being able to communicate it out. And I got frustrated with some of my colleagues because on the routing protocol side, some of the tricks that people use in Cisco, people never told anybody. And so I brain dumped, and then, getting people like Andrew Portran, Sean Duran, and others, and became the ISP Essentials document that Philip Smith and I have been maintaining. Just going through something like that on a Cisco, right? And, as you get more experience game with Juniper, to be likewise on the Juniper, some sort of document like that on Juniper, and audit those sort of configuration techniques on the equipment that works for you to help make it more secure. There's a big section in there to help make it more secure. Yes?
One of the things that would help in this regard would be allowing comments
again, any advice on vendor-specific stuff, let's take it to the end so we can write it all down. Even though I've heard most of this before and I've asked for it also. But
just for everybody else to take, the comment was, it would be nice if you could comment the configuration file.
Yeah.
As you put it in, and if it would save those comments.
To save those comments. You can put the comments in, it just won't save it. So I got on my script tools. I got lots of comments in there, but it never goes into iOS and saves it. Also, securing the routing protocol. Doing the different techniques out there. Yes, there's issues out there securing the routing protocols and being able to do things like maintain your MD5 key sets, or what do you do when you have employees leave and you have to transition all your MD5 keys, on your routing protocols. Those sort of scaling issues that were appropriate to take into either direct vendor or more in the IETF community to address the key synchronization issues. But those options are there. There's other, the things to look at, and the securing the network options. So, look at the work for that. Again, you're hearing this again, reinforcement. Know your equipment. Know the performance envelope of all your equipment, what you can and can't do. Routers, switches, all over your network, workstations. Know the capability of your network. Know what you can and cannot do on certain parts of your network, what you're capable of doing. How many packets per second are you capable of handling on this side of the network? Okay? So again, this is a ongoing process. This is kind of like this old this is kind of like a slide from the wheel group guys that Cisco simulated a few years back. This was the security team that Cisco bought was the ex-United States Air Force cyber warfare team. And they emphasize to people in Cisco, it's a constant cycle. You make your plan, you test your plan, then you monitor it, and then you're going to be working the plan, and then you do a post-mortem, and then you're back in, your constant cycle. Security, unfortunately, will not go away on us. On your identification, you know what's going to happen. One of the things I noticed out there is that some of the ISPs are doing clueful things in the sense of watching what we call the noise rates, okay? If we know as an industry we're getting all these attacks all the time, all right, there's a persistent noise level of this stuff happening. And reality, you don't really care about the noise. You just care about when the phone rings and the customer says, help, there's what we call aberration, right? So the state of the art of identification right now we have is when a customer calls you up and says, help, I'm under attack. There's the identification. But there are other things we could feasibly do that is within our scope of doing stuff. Because we know that when attacks happen and somebody who's really clueful at doing attacks, they'll do probes and map out the site to try to figure out what's going on with it. So for instance, last year, there was a couple of sites out there before the November elections. And they called lots of vendors up because a week before the attack, they were doing something very simple. I don't have this in here, but they were doing very simple. They were most people would put an access list on the VTY ports, right? Well, they put an access list on the VTY port and they log it. So they basically have two lines. They do a log on the TCP, they put the range in there and do a log on the IP, so they log it. Now what that gave them was, and they monitor this, and they put it on a little graph, MRTG graph, and they look at this, and they would see, persistent probes, because their network's constantly being scanned. People out there download a little scanner and scan their network. So they get this persistent little noise, and a week before the November 2nd elections, all of a sudden, like, boop, this thing just climbed up. Just aberration in the data, and say, oh, hey, something's going on. We're going to get attacked. When are we going to attack? November 2nd, right? Because we are a news site. We do, pump out news out there. And it happened to a couple of them that did this, and they were able to, put a plan of action in work to make sure everything is, all the bolts tightened down, all the procedures are in work to be able to counter the attack. When November 2nd came around, they were attacked. Did you notice it? No, because they were ready. They knew they were going to get hit. They were ready for getting hit, right? Because they saw the aberration of the data. That's SNMP. That's log files. That's log file analysis. Again, not rocket science. People should know how to do log file analysis. People should know how to do an MRTG sort of graph, right? So while your customer's calling you the number one way of attack, that's going on. When a customer calls you, you should, your NOC should know what to do. This is one of our problems in the industry. NOC gets called, help, I'm under attack, and the guy, oh, I don't know what to do. What's the circuit ID? What's going on? Those sort of things you should have ready to go to be able to handle attack once it's identified. Here's a nice graph that I got from one customer, blocked out to protect them, identity. But this is from NIMDA, right? The day that NIMDA started to become a problem, this is basically monitoring the CPU of a GSR. They were monitoring the CPU of a GSR, and they're monitoring as soon as you see that big jump in there. As soon as the big jump, call it, hey, something's going on. What's going on? They got an alert. Now, this could be a network problem, right? In this case, it turned out to be a NIMDA problem. And to taper off there is they say, oh, okay, this is what we'll do. And they did a couple of configurations and lessen the load on the CPU and be able to handle it with no problem. Okay, and this is what, SNMP, MRTG, putting a couple of alert tools in there, not rocket science here. And this is sort of identification things you can do an extra to add more towards just relying on your customers calling you that something's going on. And then on the IDS tools, well, they're coming out, they all tend to congregate here at NANOG. Talk to them, try them out, see how they can fit in your network. You're not going to, it'll be unlikely that you find with your network set up the way it is, because every network is different, that you'll be able to find some IDS tool that you can just go whoop, and pop down into your network. There's going to be some engineering and some work back and forth with these different IDS vendors to see if it will work with you and how you can effectively deploy it in your network. But there's some really interesting technology that's coming out of these different IDS tools. On the classification, I think we've kind of been over this before. It's important to kind of look at what's going on with the type of attack, protocol types, different types of spoof addresses. Because if you don't understand what you're being hit with or what your customer is being hit with, and you rush in, it's like the elevator analogy. That's a good one. Rush in the elevator and the elevator's not even there, and then you got a worse problem because you don't understand what you're getting hit with.
I saw that in the movie.
Oh, you saw it in the movie. Okay. And it's critical to the reaction. It's how you're going to react to attack. So this is classification stuff. And the sinkhole classification, where you can offload, because I did these slides where you use the same sort of technique with the sinkhole, and here I move it off, right? So do the classification on a sinkhole. And then a trace stack. There are actually 3 different types of trace stacks out here. We covered 2 of them today. And there's 2 different methods. This hop by hop. But one of the things that helped with some of the providers on hop by hop, here's a hop by hop. Pain to do. Okay. The other way is jump to ingress. This is kind of like old troubleshooting techniques that was drilled into me, 20 years ago, U.S. Air Force troubleshooting, where you can divide your problem in half, and it's a jump to ingress problem, where there's some tools out there, particularly flow-based analysis tools where you classify at the edge of your network where your customer is at, and you jump to the edge of your network and check on the edge of your network. Some of the IDS tools are built in that methodology where you can jump to the ingress. So instead of tracing through your network, you jump to the ingress points. Okay. So this is where the flow analysis sort of slides are for doing that. So ACLs, flow-based analysis. This is probably the only vendor-specific thing in here because this shows you here's a command to show IP cache. You put the spoof prefix in there and do a verbose flow. February 2000, the only people who knew about this command was one particular ISP who was using this command. Cisco didn't know about this command. Because, when I call them up and say, how come you were able to trace back the attack so fast? They said, oh, we use this command. And I looked and said, well, this command doesn't exist. They said, yes, it does. Try it. And I tried it out. I said, well, it does exist. Okay, who coded this? Right? And some guy coded it for them and didn't tell anybody in Cisco that he coded it for them. Right? So, the typical us Cisco, right, for doing something like this. But this is, flow-based analysis is one of those tools out there. But flow-based analysis, whether it's Cisco or Juniper, is a powerful tool because you're tracking things on flow-based technology. But don't think that you can turn it on in every single network situation. Certain networks are designed from bottom up to be able to use flow-based analysis tools, whether it's NetFlow or Juniper's flow-based analysis tools. Others have been around for quite a while, and they have a hard time turning on that flow. They have a hard time turning on the flow-based analysis. So it's a powerful tool to look at, but don't expect it don't think that everybody in ISP, because I get these things that everybody turns on NetFlow, we would be able to trace back the attack. And I tell people, well, everybody can't just turn on, this technology. All right. So that's it. And then the backscatter technique. And of course, the key three advantages of the backscatter traceback technique is to me the speed and the operational risk reduction. And then the key thing is, as more ISPs use this, you have an ability to hand off. Because if ISP A and ISP B are using this backscatter technique, they both understand how this backscatter technique comes in. You have somebody like Chris O'Brien be able to call their peers up, and the peers understand the technique, and you have from Chris O'Brien go to the next ISP to the next ISP, and then you capture the guy. And that's one of the biggest deterrents we can have out there as an industry is capture some of these guys, have a nice visible FBI, issue of cops, we see on cops where they break into this kid and lock them up sort of thing and get it nice and visible. They don't have to put them in jail, they just have to make it very visible. And that's a deterrent. That's a law enforcement deterrent that you can do out there. We can't do that very effectively today because we can't trace back quick enough. Now with the backscatter technique, we have that ability. Reaction. One of the things I get into on reactions when I work with some of the ISPs is once you actively do something, you're a part of you're a player. We've had some of my customers where they jump in there and they throw in and they start dropping packets on behalf of their customer, and then the attacker will ship the attack and attack them. Right? So you're a player. So you have to. That's one of the things to keep in mind. That's why it's okay to say that your reaction choice is to not do anything. To choose to not to do anything is a choice. And when you have, your responsibility is to your entire customer base. And in security, one of the things you got to do in security is a risk assessment. What is my risk? What is my real risk? Is this one T1 customer who's flooded worth risking all my T1 customers on that one router? That's a decision you have to make. And whatever decision you make from your scenario is a correct decision. So you don't have to feel bad saying like, well, I can't really do anything at this point because it's too risky. That's okay. Okay? That's okay. But see, with traceback techniques out there now, what you could do to your customer says, well, I can't put an access list and drop it on your behalf, but I'll trace it back. I'll trace it back on your behalf, and we'll find out where it's coming in from. Okay? So you guys work these every day. You got any comments on reactions?
I think to date we haven't seen it. We stop an attack for a customer and we become a target. We haven't necessarily seen that. At least not that we know. Router's not randomly reloaded.
Real scientific now.
Yeah. So, I mean, that's not necessarily, I think, such a big threat. I think what's probably the worst problem is customers that don't think you'll do anything for them. So if your policy is to help the customer out, if you can, then you have to let the customers know that they can call in to your NOC or your security group or what have you, and get in touch with somebody to deal with the problem. And we've had that problem. It's to your advantage for the customer to call you, because this doesn't necessarily just affect the customer, it affects your network also. You, like I said earlier, you're transiting attack traffic that you don't need to transit. You don't need to send a couple hundred mega attack traffic every day across your backbone. You'll end up paying for that eventually. So if the customers can call you, or if you can devise some magical way to know that the customer's under attack, maybe not magical, but if you can devise some way for the customer to know that the customer's under attack before the customer does, then you can save your network some headache. Yes?
What do you see more of? More server-based attacks hitting the network?
We don't generally, the question was, the question was, do we see more server-based attacks or more network-based attacks? And by server-based attacks, I'm assuming you mean a SYN flood that just chews up all the resources on the server. And by a network-based attack, blowing the customer's link out. Okay. Mostly we see blow the customer's link out because that's kind of all we will directly deal with. If a customer calls in and says, oh my gosh, I'm getting 200K of SYN traffic and it's killing my Windows NT or whatever IIS file. Okay, have you gone to Cisco's website and looked at how to make an access list? Your link's not overutilized. I mean, our policy is if your link's not overutilized, then we're not going to endanger our network for your network. I can't endanger one customer in the favor of 700 on the router. So we guide the customer into fixing his own problem, with some routing tricks on their network or what have you, to deal with it. And that happens relatively rarely, though. Most of the attacks we see are a DS3 to a T1 customer. So we'll deal with those as we can.
I think you made a good point. It sounds kind of cold saying it, but you always got to remember, that's your network. That is your network. It is not their network. It is not your customer's network. It is your network, and you have a bigger responsibility to more people than just say that one customer at some point in time. And you have to say no. I mean, it's a bad position to be in, and nobody ever wants to tell a customer no because they pay you money. But on the same end, that is your network that you spent money to build. And other people rely on the same end. So somewhere down the road, you have to make you have to think about which, the benefits and,
That's the risk of it.
Right.
Yeah.
You have to pay by volume of traffic for the time. So if you guys get that attack, that's your client. You end up having to pay traffic.
Right. So the question is, what about the levels of traffic, and both on our network and to the customer? So if, for instance, the customer is getting an extra 200K of traffic on his T1, potentially he has a burstable link or whatever it is that you call it, where it's okay to 128K, but if he goes over that, you're going to charge him extra money. Right. Our response is call your salesperson and see if they'll, if we don't stop the attack for you, call your salesperson and see if they'll give you a credit. It's not. Again, it's kind of cold, but it's the risk assessment, and I don't do billing. I can't make the bill not come, or change the bill.
Right. I think it should, the owner should be, or the emphasis should be on trying to fix the problem.
Well, this is so we take it off a unit, right? Because I deal with broad base of customers, and when I work with business consultation with them, as my role as a Cisco consultant to customers and setting up ISP business cases. And one of the things I tell them, because you get a lot of, especially internationally, I work with a lot of PTT telco types that want to, volume-based everything. And I tell them one of your cost of operations that you have to do is the ability to trace back the attacks and the ability in your billing system to be able to pull out attack, this is the attack traffic. So you have to have, if you want to do volume-based billing, this is what I usually do consultation-wise. I said, you got to have a security team to be able to, when a customer says somebody is doing a low-level attack against me and chewing up bandwidth and it's costing me money because you're charging me for this, you need to be able to help them because you want a volume-based build. This is kind of your responsibility. You have to design that into your plan. And you also have to have ability in your billing system so when the guy calls your sales guy to be able to pull that out. Now, the number of ISPs who actually go through and go to that level, you know, they say, well, I'll try to get away without it right now. But as these sort of, you know, games persist out there, what happens is, you know, companies have to come up with processes to handle that. You know, sales teams will start saying, I'm getting a lot of calls because, you know, we get these script kiddie tools and I'm getting a lot of calls from my customers to waive billing, you know, for this month, you know, and that costs money. And a smart business will find some process to handle that.
Keep in mind also that at what point do you make that determination for the customer? I mean, if they get 1K extra traffic, are you going to give them a charge back? If they get 1 packet extra, I mean, customers.
And what's your definition of attack? Some people consider a port scan attack. There's a port scan attack where they doesn't eat, I mean, sure, it eats up some of your bandwidth, but it's just a SIM scan. Is that really an attack? I mean, you get into a gray area, which is hard to deal with. But
because for us and for a lot of people, the answer is, if you're going to make a big think about it, you call sales, and sales will give you sales will call us back and say, was there really a problem? You know, what's the situation here? I don't have any idea what's going on, and they will try and help the customer if they can. But that's true. And if you look at it from a traffic perspective on our network, the reason we use the Blackwell route server is so we don't have to transit that traffic. If we can dump all traffic to that host for some period, either permanently, quote unquote, some period of time so the attack stops, or for a small period of time where we trace it, we'll Blackwell route it so we don't transfer the traffic, and we'll go find where it comes in and access what's there.
Customers are paying for it then.
Right. Yeah. I mean, well, in that case, the customer is paying for it. Because their burstable link is pushing 70,000 packets a second into our network just to get dropped. And if the customer, well, anyway, I mean, there's something like, do you really want to call that customer up or just collect a lot of money from them? And I mean, to some extent, you probably should call them up. And we do, when we know the customer will help out. But on the other hand, should the customer know he's pushing 30,000 packets a second? Come on.
Time to upgrade.
And another thing is, most of things have changed. I mean, maybe 3 years ago, you could theoretically have 150K SIM flow that actually ate up the resources on a box and killed the web daemon on it, something like that. The machines are just so robust now. I mean, you really have to pummel the machine to get the machine to die. I mean, you really have to go after the machine. I mean, almost all the time they can't do it. They can't kill the box, so they just wipe out the line. It's much easier to wipe out the line than to pummel the box. And if they do that, then the instant that happens, we have no problem doing it. But I mean, it's gray area. It's a tough call.
But I think that's very fair. That's a business case that your company needs to address. I mean, if you want to go figure out the charge back for a 1K, 1K of extra traffic, that's on you. But I don't do billing, so it's not really on me either.
Well, I was just referring to level speed. I may not swamp, but still.
Right. That's true.
Right.
That's true. If it goes higher, at a certain point in time we will help out, but most times we tell the customer activate. Because most of these attacks don't last forever. They last until the effect is had. Or there's one particular customer we have actually who has an ongoing permanent attack. Somebody, is it Czechoslovakia? Somebody in Czechoslovakia, Romania.
Some 194 block.
They have like a Class B network that's not routed?
No, they have a Class C. They have a slash 20, and they had an employee that got mad and quit, and he wrote this virus, and he infected all these machines with it, and these machines just randomly port scan the block all the time.
Yeah. So
they just null route this Class C because it would eat up their lines. Don't lose employees that are smart, I guess. Don't make your employees mad if they're smart, because they'll come back and get you.
Yeah, but most of them don't last forever. They last for a day, an hour, a couple days.
Never say never.
Never say never.
Yeah.
Most 90%.
It's an arms race. I think the key thing on reaction attack, besides having your policies straight, knowing exactly what you should do, is also to have your tools fast and flexible. And over the past year and a half since the February 2000 incident to today, you can see we're developing tools. I mean, what Chris and Brian developed with the backscatter traceback technique is something that's fast and flexible. So we got some new capabilities out there to help react to attacks. And I think on reaction attacks, the next, we're not talking specifically about this, but kind of like the next wave, and there's been debates about this here in NANOGs I've missed, because one of the code sets I work on is unicast RPF, is this concept of doing a source-based black hole filtering. Now, as our ASICs, our Forden ASICs evolve, they're evolving to the point where as your packet is clocked into the Forden ASIC, by default in that ASIC, it's designed, engineered in, that you're budgeted to do a FID lookup on source and destination, okay? Because in common sense, you need to do that sort of source and destination lookup in the FID at your line rate that the ASIC is designed to handle. So I think over the next couple of years, we're going to have the capability. The next wave of capability we'll have is the ability to do black hole filtering based on not only destination, which we can do today, but on source coming up. And that's industry-wide, because, Cisco, we did it first, but we haven't patented intentionally, so other vendors can go out there and do source-based black hole filtering, because the industry, you guys need it. We need that sort of capability as a next wave out there. And again, it could be triggered by a routing protocol update, right? Good sort of thing. Post-mortem, attack's over. Don't just sit back and say, okay, all right, go on to my next problem. Sit back and think about, okay, what was different about this attack? Look for those differences. If you created some sort of script, save it, go back on your post-mortem and clean up. There's scenarios in there that you threw up a bunch of access lists and things like that across your network to work an attack. Attack goes away, and the next attack comes, and you throw those on. And pretty soon your configurations across your network are a mess because you got all this garbage out there. Go back and clean up after yourself as part of the post-mortem. So, learn from this, learn from your mistakes. Okay. The other thing to watch out for is you'll see a lot of articles and what I call, it's kind of like the military analogy, because I'm originally a history major in military history. And you get this, the number 2 problem out there is generals fighting the last war. They look at the last war that happened. And so beware when you just look at, let's come up with the counters to counter, to be able to take care of the February 2000. February 2000 is the last war, right? If you're just stuck in that mentality, then you're not prepared when the new techniques come up. All right? Every attack scenario is going to be different on you. Okay, and being able to learn, underestimating the capabilities of your opponent is another problem that you run into. Don't underestimate. You can see lots and lots of script kiddies, but the thing that's going to really impact, the next, press visible industry-wide attack, the February 2000-like attack, is going to be one of those attacks. Just like in February 2000, people underestimated the capabilities of an attack and what it could do, visible-wise. So this is kind of like my observation. These 2 lessons from military history apply to us in this ISP security side. So, one other thing that we're getting some more experience with is watch out defaults. We had a few ISP networks go down because of defaults. Now, what happens when you do defaults? Defaults may seem convenient. And I know these guys over UNet get it, because you got a lot of people who are like, let's punt default to UNet. They're my upstream. I'll just point a default route to them. I take full routes, but I'll just point default to them. What you're doing is you say, okay, let's take my garbage, all my garbage packets, and give it to them. So, and they take it. But the other thing that will happen on it is if you have any sort of, if you have certain routers out there that will suck in traffic, and ISPs were saying, okay, I can live with default. All of a sudden, code red came about, and you had router CPU cycles climb up, and some routers crash out there because it was advertising default and sucking all the code red traffic to it, sucking all the Nimbus traffic to it. And they call a case and call it Cisco, and we say, okay, take off default. You're running full BGP routes. You can run default free. Why are you running default? Take default off of there. Right? So you gotta watch out with running default. Okay. So this is integrating with your backscatter traffic. So You guys got any comments on default? You don't run default.
We don't. We actually were talking to the guy in the audience at the last break. And he said there's kind of a religious debate in his organization about whether or not to use the default route. And I think that's the same thing really at UNet, that there is a religious debate on one hand. On the other hand, is like, where would be default route? And that for some ISPs, having a default route kind of makes sense. If you don't have a route for it because the route got withdrawn or something, you know if the traffic is really legit, you could just push it off to your upstream. We have customers of ours that default from like 3 or 4 hops deep in somebody else's network. They default. Everybody defaults. It's very strange, but you have to be careful if you default route to make sure that you put it to some place that you can do something with. Right? Otherwise, you're just sucking the traffic up to nowhere for no reason. And you can get yourself stuck in there.
I mean, we've had customers call in and say they're under attack, but they're really not under attack. What they do is they have a default route, and somebody wrote a ping script, and they wrote a test that would ping 192.168.1.1. Well, that route isn't in their routing table in the router, so they have a default route to UNet. So what do? They ping flood 192.168.1.1 across their T1 to UNet, and they just eat up their line, and then they're like, I'm under attack. Well, they're not under attack. They just had a script go wild on an IP address that wasn't on their router. So.
And on the other hand, you need to make sure that, or another thing is you need to make sure that if you do have a default route in your table, you don't send that out to other people necessarily. And be careful if you send it out. And customers get misconfigured, or we, the ISP, misconfigure a customer's connection with us and let the default route into our network from the customer. I think Brian and I have dealt with at least 2 of those scenarios. And the customer is under attack because he's getting all the traffic that would go to the default.
Sending out a default to a BGP, so lesson is know what you're pushing out. Lesson is know what routes you're pushing out to your provider as well. If you're running BGP,
a default route can be very dangerous. Useful to your customers, perhaps they should default route to you, or maybe they should.
So I think, especially the lesson after December is default route and how you engineer default route is also an ISP security question, because it impacts the security side. You can DOS yourself. Like one provider and this could be very simple stuff. I mean, one of the scenarios, it wasn't a default scenario, it was an ISP out in Asia, and they didn't have IP classless and IP subnet 0 turned on, and they got an allocation from the 64 block from APNIC, and they advertised it. Now, of course, BGP goes, and they didn't have no auto summary, so they summarized, and they sent out the entire internet 64/8. Class A. There you go. And they sucked in all the garbage, and they, DOSed themselves. So, how you do your routing protocol advertisements can do you can do yourself harm. So. And here's a bunch of URLs. I think these top URLs here gets you pointed to other URLs, which gets you pointed to other URLs. So these are different links that I think have been shown before for references. Pretty standard link. Juniper, I was talking with Juniper, and they don't have an equivalent yet, for that, because it's I guess it's more word of mouth of the different techniques that they're doing on the Juniper side. So if you're looking for something like that on the Juniper side, just when you find a Juniper guy says, hey, you guys need to write a white paper or a presentation on all the different security techniques you should do on a Juniper box. Put it all in one place. They don't have it all in one place yet.
That one link that's up there, the NANOG MTG 9910, that's Robert Stone's center track when he worked for UNet. It involves GRE tunneling to build an overlay network on your existing network. You need to be real careful with that, because if you have a big SYN flood come through, your Cisco or Juniper won't be able to tunnel that kind of traffic, and you'll lock, crash, whatever the router will disappear. So you just need to be careful with that when you look at that. It's something that we chose not to do because we just couldn't do it. We couldn't handle that kind of traffic across the tunnel network.
There is white paper under solutions and technology application of this will minimize the effects of
Right, that's the only one they have, but that doesn't, like an audit, like They don't have a white paper that says, here's how you should be placing your logs, here's how you should add, the trick with the access list about, here's the technique for adding the access list and taking it off the access list. There's, there's general things like setting the log rates. So one place where you say, here's my security checklist. Here's the things I should be doing in my routing protocols. Here's what I should be doing to protect the access of going into the router. So there's, from a security one point, you have it all there. Sort of white. I've been hitting on Dave O'Leary. I mean, Dave and I used to work together all the time, so I've been hitting on him. Says, when are you going to write it? When are you going to write it? Because having that sort of checklist is good for customers, because then it allows them to audit to make sure, here's my config, and then audit. Do I have all these things covered? Do I have all these things covered? Okay, question. We're wide open for questions now, since we have some more time. Of course, now towards the end, you can, throw all sorts of questions out.
Yes.
Bill's going to throw something.
Where an attack scenario can be isolated to a small subset of things. Where you can go out and you can say, well, I'm going to put on these access controls, but it's coming from the west side of the building.
Right.
So if I put up a perimeter, I can compartmentalize and isolate the infection to that side. And the rest of it will be happening and we can go in a monitoring way and we can fix that problem. People look at denial of service attacks from a number of different places. One of the models is that you have thousands or tens of thousands or hundreds of thousands of zombies from lots of different places. Either I was not paying attention or you covered how to fix that.
I think we'll use the mic since I think we're going to have a lot of comments on the question side. So the question was, we have because we're drawing upon a lot of operational experience from Chris and Brian on the attacks they see every day, which they're seeing more of a single host sort of attacks, and then the attacks that we hear about that we see every now and then, which to me the attacks I see are more professional level attacks where they're using the distributed denial of service tools with many different sources all over your network. So one of the things that when I first heard about Chris and Brian's technique from a couple of colleagues, and they say, hey, Unit's got a traceback technique that works on DDoS within 5 minutes. I went, well, my ears perked up, because the DDoS side, distributed denial of service attacks, where you're able to find out your ingress points from multiple locations. And so this backscatter DDoS technique, the thing that really perked me up and had me trying to sniff them out to find them was that a network the size of Uninet, where you have hundreds of ingress points, they're able to find out which of those hundreds of ingress points do they have all these potential DDoS zombies coming in from.
Somebody gave me a mic. What a mistake. In the particular case, we'll pick on Uninet 701, and you said they have hundreds of egress points. If you are equally balanced on the attack against all 100 of those egress points, what do? You just blow the bolts and turn Uninet off?
Something like Code Red, where these things are getting ready to attack whitehouse.gov, and we don't really know what to do because there's just so many of them. Let's take this. Would that be a good example?
No, that's a bad example.
Okay.
The more current or correct example would be that you have something, a denial of service attacks against your name servers.
Okay.
Right.
Like if everybody were to start attacking our name servers, let's say.
Yeah, basically sending small, really tiny UDP packets, millions of UDP packets from hundreds of thousands of hosts. What are you going to do?
I don't know. I hope that doesn't happen. I don't know. I'm being serious. If it's coming in from 250 points from 100,000 different machines, what can you do? I know solutions that we came up with on something like Code Red, I know it's not the exact same, but it was something similar where there's so many machines infected that we really didn't know what to do at the time. We just changed the DNS entry and black hole the old IP address. That was a solution. It wasn't a great solution, but it was a solution. And maybe with the DNS servers, we would have to black hole the IP addresses that were getting attacked. Hopefully they wouldn't re-DNS the IP address, re-DNS the entry, didn't get the new IP address and move it, something like that. I don't know.
If you move the DNS address, then you have to go to everybody that's got that address.
I agree. I know what you're saying. I mean, I agree.
It's a really pernicious problem in that there is no source you can go stamp on. It's coming from everywhere. And so the only thing that because I had a couple of these happen to me recently, actually Surcam was the one that had 160,000 packets per second.
Okay.
Right, really bad.
Yeah.
And so you turn around and you say, well, the only thing you can do is you can turn things off. And when you turn things off, what happened in this particular case is that the DDoS didn't go away, it went to the upstream ISPs.
Right.
So we were perfectly fine, we didn't get any traffic. The upstream ISPs had to eat that 160. Yes.
Yeah, because they had a pull-up route for you or something, aggregation route for you or something similar to that.
Yeah.
Okay. All right. Yeah. I mean, I don't know. I don't have a good answer. I wish I did. I really don't. I mean, if
Next year, or next NANOG, do you have an answer?
I mean, what it comes down to is it's pretty simple. If somebody, there's however many people out there that write exploits, and there's however many people out there that write attack code, and there's however many people out there that do whatever they do, and it takes one really smart person that knows how the internet works and knows how to effectively attack things, or to find some bug on a Juniper, or find some bug on a Cisco that crashes the router, and not tell anybody, and just get really mad and say, you know what, I'm going to root 5,000 boxes and just pummel the internet until I feel like I want to stop because I'm mad. I don't know what to do. I mean, it's like saying somebody decides to go out and blow up the World Trade Center. If you don't know about it and it happens, I don't know what to do. I don't have a good answer for that. I don't think anybody. I mean, I hope if somebody does have a good answer for it, I'd love to hear it because that's a tough question.
I think the answer we're getting to with this tutorial is to take some of the techniques that we know that works and getting as many people as possible up to speed on these techniques so they can deploy them and be ready to go with them, these techniques. So here's some more tools that people can implement. And there's always going to be, those of you out there will probably be the next people who figure out the next technique to counterattack, like Bill said. What is the next kind of technique that can do it? And it's not. Notice these techniques. It's not like because I've gotten arguments with customers. Oh, we need this feature, right? And I go like, but a feature isn't going to solve all this problem. It's usually my experiences on security. It's operators, guys out there running their networks, figuring out a new way of being able to counter this sort of stuff. And that's where the ideas are generated from. So
I think we need to also keep in mind that we've stressed 3 or 4 times the risk assessment. And that you need to make a business decision. You have to make a business decision. Is it worth it to you to do something about this? Or, like Bill did, stop announcing that route. Right? If you're, let's say you're a big ISP and you have some big network routed down to you, and it's under attack. It's such a big attack that you can't do anything about it, which was Bill's problem. Bill, right?
Right.
Bill.
That's Bill.
Let's make sure I got that right. If it's so big you can't do anything about it, stop announcing the route. Let it go away. But that's a business decision that you have to make. Can you afford to not announce this /20 block? Can you afford not to have a network for that? I don't know. I mean, that's the decision you have to make. We keep saying there's no one solution. We're not pushing, like, you should do this Blackwell route server and back everything because it's going to, be the goodness thing that gets you all this money to solve all your problems or what have you. It's not. It's one more tool in the toolbox that you can use when you have to make a decision about what to do with your time.
Yeah.
I think that the point we made is that
Maybe let's get a mic so we're.
I think the walking mic guy.
He's talking about 100,000 codes hitting a network, but where our concern is going to be is when it takes us 8 hours to trace back 5 nodes, and we were free to, we would like to start there. We can't even get a few
Right. That's 8 hours that you're down, you don't make any money.
It would be great if we had a solution for 100,000 hosts or a solution for 5 or 10 for
Yeah, I mean, you know, there's always, Bill brought up a worst case scenario. I don't have an answer for a worst case scenario because I don't think anybody ever does. That's why it's a worst case scenario.
Right, but at least if it's spoof traffic to eBay, eBay can get his 5 providers in the line, whatever the number is, say, I bet you guys, man, what's the same presentation I did? You have the backend line, can you use it? Yeah, I can see you guys you have access in front of your stuff. I hear you guys say you're going to compile the access list on your router. You can see log messages from what's going on. Right? You know that you're seeing packets from the 255 network. That network doesn't exist on the internet. But you know the attack is spoofed. Right? So you say, Unet, the spoofed attack is going to this IP address. Find it for me. I'm coming with a baseball bat. Well, I understand it's not always that easy. Right.
You're one of the few providers that will.
Well, that's the point of this tutorial, is to get more people.
Right, and that's what I'm saying. That you met me, you met the guy from Sprint, you met the guy from AT&T. I don't know if those are all your providers. Just say they are. Who knows? Could be. You tell them you were all in the same presentation with me. You said you were all thinking this would be a great idea to do. Let's do it. Get it set up so that, when next time I call you, I can tell you what's under attack. You guys can figure it out for me right away. And Brian's right. You're right. 100,000 packets, 100,000 host attacks. Haven't really seen it yet. It'd be the worst case possible. We'd all be working for a month to figure out what happened. But just the initial stuff going, if you have a set of tools that will help you get the problem solved quickly, it'll help us all. Not just me, not just eBay.
All right, so those of you who are endpoints, content servers, or whatever you call it, EB, Exodus, CNN types, the idea of getting this out there is then you can point to this. So the people who were not here, right, they're taping this, presentation's up there, our email address is up there. So you're a customer who's paying the service provider a lot of money, and you can go to that service provider and say, okay, here's the URL, here's your email addresses, we're a customer, we pay you a lot of money, we want you to do something like this. Figure it out. Or we move, right? Walk with your feet, competition, sort of thing. And they'll wake up. I mean,
Yeah. But I mean, I think, like I said before, I don't know. We've been told by a couple providers that they do it, so that some other providers are doing it now. A worry that a lot of providers have, and it's a valid worry, is that they don't want to, crash their routers, and I understand that, and I'm sure we all understand that. And so maybe they're not going to instantly put it on. They're going to test it out and see how it affects their how it affects their net, or how they think it would affect their network necessarily. You never really know until it gets out there. But I mean, that's just name of the game.
Even for content providers like eBay, I know Rob has been pointing out to me that it's a great technique for you background guys, but for me in my data center on my edge, it doesn't really help me. But it really kind of does. You can black hole the traffic and get messages from the places coming in. You can tell exactly which 3 of your 17 providers it's coming from. And you can choose to block it there, so you only black hole that that IP from 70% of the world instead of 100% of the world. It helps you internally if one of your boxes gets rooted and starts flooding out. You can easily find internally where that's coming from. If you don't have SMB specific on all that sort of thing.
Right.
That particular technique is helpful for a number of things. And Brian mentioned earlier that put it on for your, use it as a defense for your corporate network. So
works really well for that.
Yeah, we have some folks that run our corporate network and put up access in front of traffic when they have problems with stuff getting attacked, they come and ask us, can you track this back and make it stop? And we're going to go put up an access list, another line in our 1,000-line access list to make this stop. And maybe the answer isn't accessing the traffic, but just not seeing it ever again. Just black hole it, so packets come in, they don't go back out.
It's a really quick defense mechanism for security.
It goes back to just route the traffic to zero instead of processing it through an access list.
And if you have multiple links, you don't have to put it on every single link. You don't have to put that filter on every single link. Some military institutions will have 5 links, will put up 5 access lists on 5 different interfaces. That takes time. If you just black hole it from one centralized place, it's gone. You have one centralized database of what you black holed and tag it, whatever. You can write it down, or I guess if you get comment in the script page, you can comment it, or something like that.
Well, we're at the end of our time, and I'd like to close with one comment. I'd like to thank Brian and Chris especially for kind of like helping to change what I hope, and I think their hope, the change of tone in some of the security presentations at NANOG, where we don't always have the vendor talks, technology talks disguised as pushing their product sort of talks, but we get some operators sharing, here are techniques and procedures that they're using to counter some of these threats out there, and invite some of you guys out there for the next NANOG if you come up with some other techniques to get up here, whether it's on a tutorial or on it. So I'd like to really thank Chris and Brian to being brave, being UNet, and being, like Cisco,
We're not UNet.
That's right.
Right, or you're not UNet. The two guys over here. And
I want to say, though, if you guys come up with new techniques, please email them to me. I'd love to see them.
yeah.
I mean, if you think of anything,
To what we have already, or something new, let us know.
more heads are better than one.
Yeah, I used to not want to tell anybody about the Blackwell route server and all that stuff because it's our cool little thing. But it really helps to let people know because, if everybody in here does it, next time I have a problem, I can call up Travis. John will have this thing, and he can track the attack as quickly as I can. He can track it back to AT&T, and Rob will be on the phone. Rob can track it across to eBay. Hopefully not eBay, but if we can track it in 2 minutes, 6 minutes with that stupid hold down timer on Juniper, it's a big help. It's manpower savings for you, it's cost savings for you, it's security savings for you.